Yo, yo, yo. Yo, yo, yo. Yo, yo, yo. What's going on? What's going on, people? Yo, yo, yo. Okay. We are here. Looks like we are all here. Or some of us. Some of us. You guys, I've got my tea. I've got my water. Got my Coke Zero. I've got my LaCroix. Let's go. This is going to be exciting, guys. Very, very exciting. I hope everyone's doing well. How's everyone feeling? How is everyone feeling? Most of all, if I go back over here, what are your predictions? I'm curious where your predictions are going to be. How's everyone feeling for Monday? My goodness. Yeah, go for it. Let me know your question before we start. I think today the game plan is we're just going to do a lot of different FRQs. I have some questions that people have posted on the pinned comments on Discord, so we're definitely going to review those. I think that's probably going to be the majority of stuff. Of course, if someone has an MCQ, we can go over those, but yeah. Someone's asking if we're going to do series for BC. To be honest, yeah, you're probably going to be given series. Maybe perhaps if a lot of people are joining from BC, we'll definitely we can talk about like different tests. But yes, I wouldn't be surprised if you should expect a BC or a series question on the FRQ, specifically question 6. That's typically where it shows up. So be ready for something like that, guys. I think that will always be the case. All right, I'm gonna just turn off. Yeah, I think the test will be about calculus. I completely agree. Yeah, we can review some series, that's for sure. But again, it all depends if a lot of people want to go over those things. Typically, to be honest, when people are here, they want to review the AB material, which is going to be on, units 1 through 8. So I think that's going to be important. Yes, we've done implicit differentiation, but I think today we can definitely go over those. I don't know. So to be honest, someone's asking if there's going to be a polar. I think it's going to be a polar or a, a parametric. But if I have to guess, because we haven't done polars in a very long time, in fact, let me go ahead and pull up. There's a pinned comment that someone had posted a while back that has the predictions for 2026. I think it's this one. Let me just go ahead and download it, and I'm going to show you guys. These are the predictions. This was something that some AP or someone on the Discord, he might even be on here. These were a picture that someone posted. I believe it's a math creator or a math content creator on YouTube. But these are the past BC exams or the FRQs for the past 15 years. And if you'll notice for question 2, it's like particle motion, polar, polar, particle motion. And by particle motion, they mean parametric, polar, parametric, polar, and then the pandemic. And then look at this. Since 2021, parametric, and then polar. So I don't know, guys. I'm thinking it's gonna be a polar. I'm really thinking it's gonna be a polar. That's just me, I think. Um, yeah. I think a polar is for sure gonna be something that will be on there. Why not? You know? So let's just kind of let's kind of go over some questions. Some people had posted first of all, someone posted this on Discord, and I don't know how I feel about that. This question is brutal, and I really don't think, I mean, I'm gonna guess there's absolutely no way that something like this can show up. No way. There's just no way that a problem like this will show up on the FRQ or even the MCQ. So I definitely don't see that happening whatsoever. But yeah, I mean, if you guys wanted to do these, go ahead and practice them on your own. But one thing I will suggest before we even start, just for practicing problems, I want you to have a pen or a pencil or something that you want to write with, a marker, and then of course a notebook or a pizza box, a cardboard box. It doesn't matter. I want you to try to write some stuff down. So if you see some problems, the whole point, again, today is kind of just like a speed run. We're just prepping. You know, at this point, we should know, or at least I would expect that we know a lot of the material. Today's just going to be laid back. We're just going to write as much problems as we can, kind of get our brains warmed up, just, registering some certain concepts and formulas. So I would not, I don't want you to think like this is where we're going to cram everything, because that's just not going to be the case. You know, this is Saturday. Tomorrow should be a very low key day for you guys. So I want you guys to just get a piece of paper, a pencil, a pen, your iPad, whatever. And I want you to write some stuff down. Even if you're just doodling, if you're like, oh, this is how I would do it. Okay. That's totally fine. I want you guys to just be chill today. I want to just review as much as we can. And to be honest, that's how you kind of get better, right? This is no stress, I would say. All right. So let me just go ahead and pull up an FRQ. Someone's asking if this is BC, I think. Speaking of, I guess let me know in the chat. Were you guys doing AB or BC? That's going to be the real thing. Maybe we can switch around from BC to AB, but for the most part, because we're doing a lot of AB material, everyone here is for sure going to be doing AB material. That's the majority of what we're going to focus on, if I'm going to be honest with you. So we just kind of have to be ready for that. Okay, let's kind of just let's warm up by not doing anything crazy so far. Okay, let's just kind of start off with a question like this. Okay, nothing insane. This is a typical MCQ problem that they can give you. And what you have here is you have a function f defined by f of x is equal to 2x plus x to the power or e to the x. And then they tell you that g of x is considered the inverse function for all values of x at the point 0, 1. So this is one of the important things, okay? This is very, very important. So one of the things that you should keep in mind, if they already told you this coordinate 0 to 1, when x is equal to 0, y is equal to 1. So the inverse will be the other way around. When x is equal to 1, y will equal to 0 for the inverse. And that's typical. This is a typical problem they'll give you, because now I'm going to switch. First, I'm just going to write this down so that we can kind of, you guys are not lost in the problem here. 2x plus e to the x. We know that g of x is considered the inverse, and then we know f of 0 is equal to 1. So what we got to find, or what they want us to find, is g prime of 1. Okay, so I have the material here. We're told f of x is equal to 2x plus e to the x. G of x is considered the inverse. F of 0 is equal to 1. Find g prime of 1. Maybe some people already know the answer to this. But one of the things we have to remember, okay, that g prime of x, the derivative of the inverse, is 1 over f prime of g of x. This is important. Very, very important. This is considered the derivative for the inverse. So whenever you have an inverse function, it's 1 over f prime of g of x. So if we have g prime of 1, which is what they're asking us for, then we'll have 1 over f prime of g of 1. Let me just go ahead and put that there. Well, that means that we need to find g of 1. Okay, well, how do we know that? Well, they already told us f of 0 is equal to 1. When x is equal to 0, the y value is equal to 1. Therefore, the inverse will work literally the opposite. G of 1 will equal to 0. So going back to our derivative, g prime of 1 would be 1 over f prime of 0. So now what we got to do is find that particular f prime. And we need to find f prime of 0. Well, up here, we know our f. So let me just go ahead and bring it down. F prime of x is equal to 2 plus e to the x. And now plug in your 0. F prime of 0 is equal to 2 plus e to the 0, which is just 3. So then now to finish off our problem, g prime of 1 will equal to 1 over f prime of 0, which was 3. So our answer should be 1/3. So I'm going to go back to our problem, and 1/3 was our answer. That will be B. Common. And to be honest, it's kind of, if they give you this on the FRQ, it will be like part C or part D or something like that. So definitely just be mindful that something like this will show up on the multiple choice. I've seen it many, many times. Every time we're doing like, MCQ review, this is typically what happens. All right. So yeah, very, very simple. Okay. There you go, BC Cuber. You actually showed up. Yes. Thank you so much for being here, dude. So that was an MCQ that someone provided. Once again, you guys can totally go to the AP Calculus Discord, and that's where you guys can post your questions. But I'm going to pull up another problem that showed up. So let's go ahead and do one. Okay. Guys, we're jumping straight to an MCQ. Again, keep in mind, today we're doing a speed run. We're kind of just laid back. We're studying, it's 6 o'clock in the east, on the West Coast where I am in Seattle. I'm sure it's like 9 o'clock in the East Coast for some people. So no pressure. Today, we're just prepping. And then tomorrow, we'll just chat on Discord, and we'll make sure that we get as many problems down. But at this point, guys, no, we're chilling. We shouldn't be too stressed out. At least I hope that's the case. Okay. So let's look at what we have here. Consider the curve given by y cubed minus xy is equal to 2, and it could be shown that the derivative is equal to this. Wow, they already give it to us. They already told us the derivative is equal to that value. So that's important. That's kind of nice. Typically on an FRQ, they'll tell you to find the dy over dx, but in this case, it's already there, which is really nice. So then we go to part A. Write an equation for the line tangent to the curve at the point -1, 1. And for those of you joining, as I mentioned, grab a pen or a pencil, a paper, anything that you could write on, okay? Whether it's your desk, your foot, I don't care. Try to scribble this away. Try to solve this problem for part A. Write the equation of the line tangent to the curve at 1, -1. Well, what I'm going to do first, I'm just going to write it out on my end. So we have y over 3y squared minus x. I should have written the function first. Y cubed minus x, y is equal to 2. So what we got to find is the equation of the tangent line at -1, 1. So -1, 1. Okay, so let's go to my blackboard here. Here's the stuff. Equation of the tangent line. Even if this is an FRQ, I know they're going to be asking for a question like this. So this is the tangent line, okay? This is a common problem, common question that we should have, especially I know that they like to ask that on the MCQs as well. So equation of the tangent line, here you go. Well, we need 2 points, x1, y1. We have it in the -1, 1. So now we have y minus 1 is equal to m times x minus -1. Well. In this particular case, we need the m, and the m is the slope at that particular point. So I can just say this is dy dx at -1, 1. So we'll use the derivative that we have on top and plug in -1 for x and 1 for y. So then that gives us 1 over 3 times 1 squared minus -1. Let's simplify this. 1 over 3 plus 1, so 1 over 4. Okay, so our problem, our solution will be y minus 1 is equal to 1/4 x plus 1. And guys, on the FRQ, we leave it like this. This is fine. This is going to be totally fine. All right, you don't have to do anything with it. We are good to go. That's it. And a lot of the times I'll actually mention, sometimes with these problems, they'll say approximate, the function at, it will be like -1.2 or something like that. Well, then you will plug in -1.2 for x if that's the case. But again, we're not doing that right now. This was just part A. Let's go back to part B. Find the coordinates of all points on the curve at which the line tangent to the curve at that point is vertical. Vertical, guys, that's going to be the most important thing. Ooh, this one's interesting, and I'll tell you why. Okay. So find the points at which the curve is going to be vertical. Wow, this one's actually really nice. Okay, let me just write the equation down. I guess maybe I should go back over here. You'll see in a second what I'm thinking about. Okay, I'm just going to erase this. Okay. All right, let's go back to my blackboard. Well, we want to find when things are vertical. Well, when things are vertical, it's when, oh yeah, someone said negative 1/4 x plus 1/4 plus 1. Yes, you can totally bring it to the other side. You can leave it like how I left it. That was fine. Okay. Yes, use the bottom. When something is vertical, we need to set the bottom equal to 0. So I guess that's really what we're trying to find. When does it equal to 0? That's the important thing. If it was horizontal, then we set the top equal to 0. So we're going to do 3y squared minus x is equal to 0. And look what happens. This is interesting because we have an x and a y. Well, let's add the x to the other side. And then what we'll do is we have 3, or I guess what we can do is y squared is equal to x over 3. We'll divide that. And then we have y is equal to plus or minus root x plus 3, which is interesting because you're like, okay, well, what can I do with that? Don't forget the plus or minus, because now what we have to do is we'll plug this in, this entire thing, in for the value of y in both problems, which is crazy. I don't know if this was a calculator portion, whoever wrote this or whoever suggested this. It was Tingle always bet, something like that. I don't know if this was a calculator portion, but we're going to plug it in. All right. So now what we have is we'll do the positive one first. X over 3, or let's do cube root of x over 3 cubed minus x times cube root of x over 3 is equal to 2. This is diabolical, to be honest. This has to be, in my opinion, it has to be a calculator portion. Yeah, this has to be a calculator portion. We'll go to it in a second. In fact, if this is, oh, it's not. Ooh, okay. It's not. That's insane. Okay. Well, then we'll definitely do that. It's not. I guess the way we're going to solve it is I'll factor out an x cubed from everything. And then now we have root x cubed, or we'll factor out a root x over 3 from both. So we have a root x cubed squared minus x is equal to 2. There's no way. There's no way you're supposed to plug in. I hope I didn't plug anything wrong in this case. The 3y squared into x. Okay, so let's try that. So this is what someone said, and I think this is probably going to be better. So what I ended up doing is I solved for y, which gave me some crazy value. Okay, I solved for y here. But then someone's suggesting in the comments, and this is what happens, guys. This is why we're reviewing this. Someone said, you know what? Why don't you just plug this into your x over here? And I think that's exactly what I'll do. That's a better suggestion. So sometimes, I guess, again, this is why we're reviewing things, because if you get it wrong, holy crap, hopefully you can come back and be like, let me try a different method. And yeah, I honestly would have been totally stumped if I took this on the exam. So let's plug the value of x in for the value of 3y squared in for the x. So we have y cubed minus, this is going to be so much easier, 3y squared times y is equal to 2. So now we have y cubed minus 3y squared is equal to 2. Wow, so much easier. It would actually be 3y cubed is equal to 2. Negative 2y cubed is equal to 2. Y cubed is equal to negative 1. Y is equal to negative 1. You guys, yeah, that is much easier. That is way, way easier. Okay, thank you. Okay, so what I found is y is equal to negative 1. So then I plug it into the expression that I had here. So 3 negative 1 squared is equal to x. So 3 is equal to x. So it looks like we have a coordinate 3 comma negative 1. We'll make this value 0. And here's how we can do it. Look at the bottom, the denominator. We have 3y squared minus x. If you were to plug in the values, you would have 3 times negative 1 squared minus 3. You get 0. At the same time, y can also equal to positive 1, it looks like. And I think that's important because it says find the coordinates of all points. And the way I knew that is because when I took the square root, or would this be it? Actually, I mean, I'm going to assume that this will be the answer. I kind of wanted to do y is equal to negative 1 as well, because technically 3 comma 1 also works. So I would definitely do both. Yep, I would definitely do both. Super tricky. The main thing here that you have to keep in mind that if something has a vertical asymptote, then what we have to do is we have to set the bottom equal to 0. Okay, so let's look at this, the next section. For part C, evaluate the second derivative at the point of the curve x is equal to -1, y is equal to -1. So let's talk about this. Well, keep in mind, we already know the first derivative, which is nice. So all we have to do is just take the second derivative and then plug in -1, comma 1. All right. So we have to find d squared y over dx squared at -1, comma 1. So let's go ahead and take a look at our derivative, which was dy over dx is equal to y over 3y squared minus x. So as we take the second derivative, we have to implement the quotient rule. So we'll do the bottom function times the derivative of the top, which in this case it's 1, but don't forget we have to include that dy dx minus y times the derivative of the bottom function, which will be 6y dy dx minus 1 all over 3y squared minus x squared. Okay, so now we can go ahead and plug in, we can plug in -1, comma 1. Now we have these dy dx's. So what I would like to do, you can plug, you can plug this back into your function, but we're not trying to simplify this. We're trying to find the derivative. So what I will do is first find dy over dx, which I think we found was 1/3 in part A. Is that what we found? Was 1/3? Yeah, it was 1/3. Or it was 1/4 in part A. I shouldn't have erased my work. So now we can just plug in the 1/4 in for here at -1, comma 1. So that will give us 3 times -1 squared, or 3 times -1 squared, or 3 times 1 squared minus -1. And then we have times 1/4 minus, and then we have 1 times 6 times 1 times 1/4 minus 1 all over 3 times 1 squared minus -1 squared. And again, we kind of already know what these values are. Let's simplify this. The first parentheses becomes 4 times 1/4 minus, and then we have 6/4. In other words, I guess we can do 3/2 minus 1 all over, and then we have 4 over here. So we continue simplifying. 1 minus, and then we had 3/2 minus 1, so we'll have minus 1/2 over 4. And then we have 1/2 over 4, and we'll have 1/8. I'm hoping that's correct. Oh, 1 over 32. See, did I do my math wrong? Correct me if I'm wrong there, okay? But as you can see, what the hard part of this whole thing is to actually do your algebra. I could be totally wrong. I got 1/8. Oh, again, if I'm wrong, please let me know. I did my algebra wrong, and that's typical of me. That happens many, many times. Did I forget to square the bottom? Ah, thank you so much. There you go. See? Wow. I think, I guess I could be rusty right now, or maybe I'm just I'm nervous, or I just suck. Yeah, guys. So this was, the bottom became 16. So going back to this, it was 1/2 times 16. There you go. So then 1 over 32. Wow. Damn, if I was taking this exam, I would tell myself to lock the fuck in. Ooh, that was pretty nasty. Not good. Okay, we're gonna get better as we go. But thank you. Someone corrected me. 1 over 32. Your algebra is pretty, can really catch up to you, and it can really make things difficult for us. There was one question that people wanted to review, and that is, we want to do a like an area one. I definitely want to do one of those, an area problem. So let's just go ahead and find that real quick. Okay. But as you guys know, you guys can always post your questions in the Discord. But as we do that, I'm going to find an FRQ problem that involves area. And what I actually like to do is I like to go to my Google Drive over here. I'm going to show. Here we go. I have a Google Drive of a bunch of different questions, which is actually in the pinned comments that you guys can go over. And I personally like, there was this one here, Calculus AB FRQs. And I want to do one of these problems. We're just going to zoom in. We're going to pretend that we don't see these answers, blah, blah, blah. Let's not worry. Let's do this one from 2000. Okay. And this is for sure a calculator portion. Okay. Hopefully you guys can see that. So they tell you that let R be, I'll just kind of leave it like that. Let R be the shaded region in the first quadrant enclosed by the graphs e to the negative x squared. So they have like a Gaussian integral. And then y is equal to 1 minus cosine x, and the y-axis is shown. So we need to find the area of region R. This is the calculator portion. Okay, so if you guys want to pull up Desmos, you want to pull up your TI-84, which, by the way, you should totally have charged already. We should be ready to go. Okay. We should have those. Let's do. Oops. Here we go. Yeah, we're gonna go on Desmos real quick. So the very first thing, if we want to find the area, well, we need to find where these functions intersect, because it looks like our integral will start from 0, and then we need to find where these functions intersect. So let's go to Desmos, and let's just graph this thing. I'm gonna do f of x is equal to, which one was, I guess it's not gonna matter. The top function, I'll make it the Gaussian integral, negative x squared, and then the other one, g of x, is going to equal to 1 minus cosine of x. Whoa, what's going on here? There you go. So if we zoom in, you'll notice that it intersects at 0.941. I'm going to do 0.941 just because that's nicer. And because on the AP exam, you can just truncate it to 3 decimal places and you're good to go. So we need to find the area. So I have e to the negative x squared, and then the other one's 1 minus cosine of x. Okay, so remember, if we're trying to find the area, well, we need the area from 0 to 0.941. And from here, we can do e to the negative x squared minus 1 minus cosine of x. Be very careful with these parentheses if you're going to write it like this. I feel like you can say f of x is equal to e to the negative x squared. And I can state that g of x is equal to 1 minus cosine of x. And then from there, I can just instead write the integral 0 to 0.941, and then do f of x minus g of x. And I think that will be okay because you're defining your function. I think that's totally fine. Okay, we'll see if this has a disk and washer method. If not, we'll literally just do it. Even if it doesn't have it, we'll assume that it's there. All right. So here we go. We have these problems. Going back to this, oh, now we can just find the integral. Well, what you can do is take I and t. Again, if you're doing Desmos, a lot of people at this point might not know how to do this. You put I and t, and it'll give you the integral. So you do 0 to, what do we say, 0.941. And then this is why I define my function, because I could just do f of x minus g of x. Close this. There's my dx. So 0.590. Oops, wrong one. There's my function, 0.590. You can even round it to 0.591. I think that's totally fine. In fact, we'll check the answer in a second. We'll kind of scroll down. See, they told you that it does intersect at that value. And then the area is 0.590 or 0.591. Yeah, that's not bad. That is not bad. Kale, nice to see you, dude. All right. So let's go ahead and do part B. Now that we can kind of like show the answers because we just did part A, look at part B. Find the volume of the solid generated when R is revolved about the x-axis. So that's actually really easy. It's just revolving about the x-axis. Well, let's go to, ooh, we should go to our blackboard. By the way, sorry. I guess I never showed the answer. The answer is right here. They told us that x is equal to 0.941, and then the area 0.590 or 0.591. Okay. But then for part B, find the volume of the solid generated when R is revolved about the x-axis. Well, let's check that out. Okay. Well, if we're revolving about the x-axis, this is the line. Let me just draw it a little bigger. This is the line in purple. It's revolving about the x-axis. Okay, not bad. Well, we should probably kind of already know that we're going to do washer method because we're going to have two radius or radii. We have the large one, and then I guess I can do a different color. And then we have the smaller one. That's the important thing. So then for part B, our volume will be pi from 0 to 0.941. This is why it was important to know where they intersect. And then we're going to have, we can do f of x minus, I'm just going to put 0 squared minus g of x minus 0 squared. Because remember, the washer method tells us that we need to take the top value minus the axis of rotation. So I just put it as 0 just to kind of get the point across. If it was something else, then we will put that value minus, and then we put the smaller radius. Okay. I see some people already posting more comments on the Discord. So I'm going to do, I don't even know if that's what they want, but let's go ahead and find out what this value is. All right. So let's go back over here. Let's go to Desmos. Well, in this case, I guess we could just do, I mean, it's the same thing. I'm going to put a pi up here. And then I am going to do, so we have f of x minus 0. Again, just to drive the point across, you don't need to do that. And then I'm going to put g of x minus 0 squared. There you go. And there's our volume. Our volume is 1.746. That's how I'm going to write it down. 1.746. We go to our solution, and 1.746 is exactly what they want. Not bad. Okay, let's go to the last section. C, the region R is the base of a solid, typical. Each cross-section perpendicular to the x-axis is a square. Find the volume of the solid. This is important, guys. So, because they want the, I guess I should probably just erase some things here. Let me go ahead and just erase this part, okay? Because they want a volume, they want the cross-section to be squares. So what we have is, let me just erase this part, and I guess this part. Oh, I guess I should have just redrawn the whole thing. It's kind of unfortunate when you have this. Okay, but there you go. So the idea is that you have this cross-section, and you can say this is, some people call it the B, some people call it the S. I'm just going to call it the S for now. So you have this cross-section. This is S, and it's in the shape of a square. Well, the area of that is just S times S. So the area is S squared. So our integral, our volume for this integral is going to be the integral from 0.0 to 0.941 of S squared. And how do we find S squared? Well, if we look at the function, it's the top function minus the bottom. In this case, our g of x. So what we would do is do volume, or I guess we can just do integral from 0 to 0.941 of f of x minus g of x. Remember, I define my function, so I can write this. Okay. That's it. And they want us to find the volume, so we have to go back to our slideshow. Or I keep calling it the slideshow, but our screen, I guess, our problem. And in this case, I'm just going to do no pi. So I'm just going to integral from 0 to 0.941. And then I'm going to write f of x minus g of x. Square that bad boy. And don't forget your dx, guys. Your disrespect to x. And there's our volume. 0.461. That's our volume. Piece of cake, I would say. If we go back to our problem, let's see. Our volume 0.461. There it is. By the way, guys, you guys can totally find this on you guys can totally find, actually, I'm just going to link it in the comments. Give me 1 second. Let's link this. If you guys want to post your questions on Discord, you guys are more than welcome to, but let me just go to the chat here. Okay. There's a good go. Boom. Tagged it. Get it for you guys. There you go. You guys can look at this. And again, this this Google Drive, or I guess I should also link the Google Drive as well. This entire Google Drive has a bunch of different problems. Let me just tag that now because I know that's going to be super helpful for you guys. So let me share this. Give me go back to this. Almost. Okay, yeah, let's do an integral when we cover with respect to y. That'll be important. Let's go ahead and do that. Give me a second. Oh, I see that I'm lagging a little bit. I hope that's okay. I wonder why. Oh, it's because I'm on Google Drive. I hate that. Okay, I'm just gonna delete that. Okay, we're gonna do one where we have to do with respect to y. Let's find a problem like that. Okay. We're gonna do one like that in a second. I want to do if someone could find a one where you have to do it with respect to y, or I guess we can just create it real quick. Okay, just because we don't have to do. It's really not that hard. Now I gotta say on the AP exam, typically they will already give you the functions, and they already would address it that it's like in respect to x, in respect to y. But let's just say, for example, you have root x, and then you have the square root of x. Okay. And they want to find the area. Let's just say that's the case. Okay. Let's just say for whatever reason, that's what they want you to find. And then they mention something that this region is revolving around the x-axis. So once again, this will be my axis, and we're revolving about that. Well, it's essentially the same thing. It's pi from A to B. Let me change the thickness of this pen. It'll be pi from A to B. But now what we need is an f of y minus the g of y. And the way some people like to also think about this, it should be f of y squared minus g of y squared. Maybe I should change it into the radius. Let me just do that real quick. Minus, and then lowercase y squared. Okay, so we have two radius. One, this large radius, which is the function on the right minus the axis of rotation. And then we have the other one, which is going to be the axis on the function here on the bottom minus the axis of rotation. So, and what I mean by function on the right is the one on the furthest to the right, and then the function on the left minus the axis of rotation. And the thing about this is you gotta change these functions into terms of y. So this one was originally y is equal to x squared. So if you take the square root, you actually get root y is equal to x. This is why I'm telling you that the College Board or the AP exam will just give you the problems. And then the other one, this one up here, which was originally y is equal to root x, will now be x is equal to y squared. So they intersect at the coordinate 1, 1. You can kind of just find that very easily. And so our volume will be the integral from 0 to 1, because that's the direction from 0 starts. That's where the y starts, to 1. That's where the y ends. And then so you write, now you're doing the function on the far right, which is going to be root y minus 0 squared, minus, and then the function on the left, which is going to be y squared minus 0 squared dy. And then you solve it that way. This is typically going to be a calculator problem. So just keep in mind that we're literally just going to write it like this. Okay. Someone's asking for the Discord link. Can someone find? I know someone is from here on Discord, and they can do this. Okay. Someone asking about. I'm just going to put like a BC question. We'll probably put that closer to the end, unfortunately. Okay. Just because I know a lot of people are here for AB, and I kind of want to just try to do as many problems as I can. Okay, let's go ahead and do, I'm going to pin that. There was one that was, let's do a velocity problem. Let me go ahead and put this over here. Oops. Okay, Ooh, you guys, check this out. AP Calculus AB 2025, just last year. Some math nerds were reviewing this. Some math nerds were doing problems like this. Yes, so if it's also in terms of y, they're going to be given the line x is equal to a. Yeah, good call. Thank you, Banana. When would you subtract anything more than 0? Let me go back to this because it seems like some people might have some questions. Okay, so when would you subtract anything more than 0? If in this case they said that you're revolving about the line, let's just say x is equal to -2, then what will change is you will subtract this. You would do minus -2. In other words, I guess I can just do like root y minus -2 squared. And the other one is y squared minus -2 squared. Okay, that's the important thing to remember, is that you're doing the function on the far right minus and then whatever axis of rotation is. In this case, because they are asking us to rotate about the y-axis, then x is equal to 0. Okay, so when they talk about the y-axis, it's like x is equal to 0. When they talk about the x-axis, it's y is equal to 0. And again, guys, if you guys have any questions, you guys can go on Discord and, chat, because there's a lot of people that are commenting and asking questions about this. Okay, so let's go back to problems like this one. This is a particle motion problem, and it's problem number 5. So I believe we can already assume that this is a non-calculator portion. Correct me if I'm wrong. I believe question 5 will be a non-calculator portion. So, quick question. Someone says, how do we know when we do how do you know when something is between in terms of dy over dx? To be honest, the big clue, if they said the y-axis or the line x is equal to something, that's in terms of y, because you're drawing your horizontals or you're drawing your radius in a horizontal fashion. So in this case, what we have here, these are horizontal right here. So this is in terms of y. If it was the other way around, typically they will say the y-axis or the line y equals something, then it will be in terms of dx. Okay, so now the particle motion. Two particles, h and j, are moving along the x-axis for time 0 to 5. The position of particle h at time t is given by this. This is the position, keep that in mind, and the velocity for particle j at time t is given by this function. So we have velocity for one and then position for the other. Okay, so for part A, find the velocity of particle h at time t is equal to 1, and we have to show our work. So once again, guys, hopefully you guys have a something to write with, and you guys are just kind of writing these things down. I'm going to write the function down on my iPad here, and then I'll switch you guys over to that. H of t is equal to e to the t squared minus 4t. To be honest, this is 2005. You're looking at something very similar. Something like this can show up. I mean, it's pretty common. I mean, I guess what we're trying to find is we're trying to find velocity of this at 1. But don't forget that velocity of this particle is equal to the derivative of the position. So what we have to do is implement chain rule. We have et squared minus 4t times the derivative of that. So 2t minus 4. Okay. All right. So let's go ahead and plug in 1. So we can say velocity of 1 is now equal to e to the 1 squared minus 4 times 1 times 2 times 1 minus 4. Well, let's just simplify this, and I think we can just leave it like how it's simplified. E to the 1 minus 4, so -3 times just -2. -2 e to the -3. And that's it. This is literally part A, guys. They want us to just find the position or the velocity at that point. Okay. Someone's asking for the link again. Let me just do it real quick. I will find it for you guys. Hopefully, it'll be quick because I'm doing it here from my phone where I'm reading the chat. Boom. Okay, sent it. All right, so this was the velocity. Let's go to the next problem, or part B. All right. During what open interval are particles H and J moving in opposite directions? This is interesting, okay? Because what we got to find is we got to see where it's changing in or where it's moving in opposite directions. And this is from 0 to 5. So you kind of have to do some work here, okay? Because first we need to find when the particles are moving to the left and right for J and when it's moving to the left and right for H, okay? So we have to do some work. Let me just erase some things here. Let me go back, and as I'm writing this, you guys can totally start doing this on your own and just kind of see like where this will go. Okay, so let me just erase some things here. So we got to find when these things are moving in opposite directions, but let me just find, or I'm going to write the velocity for J, and then that's 2t squared minus 1 cubed. And then we're looking for just between 0 and 5. Okay, so we have the position and the velocity for both. Well, actually, no, we have the position for one, velocity for both functions. Well, in order for us to just see where they're moving in opposite directions, we need to find when they're at rest, when they're at 0. We need to find the critical points and then kind of do some work from there. So what we know, for example, let's do the first one for v of h. If we set that equal to 0, well, you're doing 2t minus 4 times e to the t squared minus 4t is equal to 0. And guys, even though this is a non-calculated portion, just keep in mind, e can never be 0. It's an exponential. So we really just can say, we can disregard that function and just ask ourselves, when is this equal to 0? And we find that t is equal to 2. So we can draw our number line. And don't forget, we're going from 0 to 5. And we have 2 here. This is how I personally like to do it. I just do a number line. And I'm going to plug in some points. T is equal to 1. T is equal to, let's just say, 3. Okay, so we're going to plug this into our velocity. So the velocity of h at 1. Now, this is the velocity up here. So when you plug in 1, you get 2 minus 4, which is going to be a negative. And then e to the 1 minus 4. This doesn't matter. In fact, we kind of already know what this, we kind of did a problem like this. This is going to be negative 2, e to the negative 3. Doesn't matter what it is. We just know it's negative. E is always positive in this case. So we say that we have a negative here. And then when you plug in 3, you're more than likely going to get a positive, but you can just double check your work. You're going to do 2 times 3, so 6 minus 4, e to the, whatever this is, I'm just going to put 2 or 3 squared, which is going to be 9 minus 12. But again, that doesn't matter. We get 2 e to the negative 3. So that's positive. Yeah. So now we say that this is going to be positive, but then now we know it's moving to the left from 0 to 2, and it's moving to the right from 2 to 5. But now we have to do the other function. Okay, now we have to focus on this one as well. Well, we have to set it equal to 0. So 2t, t squared minus 1 cubed. And then we have t is equal to 0, which doesn't matter because our interval is from 0 to 5. And then we have t is equal to plus or minus 1. So I set the 2t is equal to 0, and then I set the other parentheses equal to 0. Just did some algebra there, just factoring. So what we really have in terms of our number line is we have 0 to 5. We have 0, and then we have 1. I'm just going to put 1 here. Okay, well, if you plug in, like, let's just say 0, 0.5, I want you to kind of think about what happens here. Okay, let me do it. Oh, I guess I'm just going to do it right above. I shouldn't have done that. I should have just put it on the bottom just because I didn't want to erase anything. Let me just do that. Okay, so when you plug it in, you have 2 times 0.5, which is a positive, but you have 0.5 squared minus 1. That's going to be a negative, and then you cube it. That's also going to be a negative. You got to kind of, you can work it out, or you can kind of just look at that like, oh, that's going to be negative. You can just say that's going to be negative right there. That's a little hard to kind of show, but once again, the reason why I know that, 2 times 0.5, well, that's just 1. But then on this one over here, 0.5 squared is 1/4 minus 1, which will be a negative number. And then when you cube a negative number, you get something that's negative. You got to use, unfortunately, some algebra there. Okay. So now we're going to plug in, let's just say t is equal to 2. So 2 times 2, which is positive. 2 squared minus 1, that's going to be positive. Cube it, all that's positive. Okay, so here's what we have, guys. We have two number lines, and we have to find when they're moving in opposite directions. So what I can do, do I even have this thing? Yeah, I do. I can move this entire thing down here. I want you to kind of look and compare, okay? This is the important thing. So from 0 to 1, they're moving in the same direction. Because from 0 to 1, they're moving to the left, and then from 0 to 1 down here is still moving in the same direction. But then from 1 to 2, it's moving in the opposite direction. And then from 1 to 2, let's just say, for example, on top, it's moving to the right. So we can just say they're moving in the opposite direction from 1 to 2, and then from 2 onward, it looks like they're both moving to the right, and then from 2 onward for the other one, it looks like it's moving to the right. Again, if you were to draw out like if you were to put a 2 here, or if you were to put a 1 there, you can kind of see that difference. So when is it moving in opposite directions? So you can say opposite directions, from 1 to 2. And I don't know if you're going to have to justify that because I kind of drew all my stuff, but I feel like you can say it because they have opposite signs. Their velocity have opposite signs. Yeah, this was pretty nuts, but it's a non-calculator portion. That's why. All you have to do is just break it down. So let's go to part C. I love math too. It can be shown that the derivative of the velocity at 2 is greater than 0. Is the speed of the particle increasing, decreasing, or neither at time is equal to 2? Ooh, so if the speed of the particle j, that's the important thing. So keep that in mind. The derivative of the velocity, in other words, the acceleration is greater than 0. Well, let's go back to this. We're looking at j. So we're looking at the second one over here. We're looking at this one. So at 2, we kind of found that it was positive. So I guess for part C, let me just kind of do that for part C. We found that the velocity for particle j at 2 was positive, okay? Because we had just tested that. And now they told us that the derivative at 2 is also positive. So we say since they have the same sign, it is increasing or speeding up, I guess. Oh, we can say, I guess we can just change that verbiage. Sign, the speed is increasing. Because don't forget, if they have the same sign, it is speeding up. In other words, the speed is increasing. If they have opposite signs, it is decreasing. Boom, there you go, Russian penguin. Thank you so much. That's exactly what it is. Okay, that's it. And I hope they give you a problem like this. If this is question 5, bro, I really, really think that will be the case. In fact, let's just kind of look at some predictions over here. I'm just going to show you. Let's go back over here. So last year, you'll notice, let's see, pink is particle motion. So every year since 2021, particle motion. They had a particle motion for question 6 in 2022. Particle motion, particle motion. Last year was a particle motion. Bro, we should expect a particle motion, right? We should expect a particle motion. A particle motion is going to be part of this, our identity when it comes to this. It's just what's going to happen. And that's pretty exciting, to be honest. Because we should already be thinking, oh, for sure we're gonna have a particle motion. Go on Monday and have a particle motion. If they don't, I want you guys to go on Discord and yell at me for that because it looks very, very common. I mean, look, we have a graph analysis, table question, area volume. I mean, graph analysis for sure, a differential equation, a particle motion problem, and then implicit differentiation seems like it's just fair, like making a comeback 2024 and 2025. So, yeah, pretty exciting. Okay, so let's go to part D. Oh, give me 1 second. Guys, my wife is letting me stream for 3 hours for you guys. And I was just texting her, telling her, thank you so much. Thank you. Okay. If I'm wrong, that's going to be crazy. I mean, again, I'm looking at the predictions. The universe does like to play tricks on me. So if I'm wrong, bro, that is gonna be insane. Yeah. Okay, so let's look at D. All right. So particle J, we're looking at particle J, has a position of 7 at t is equal to 0. Find the position at particle J at time is equal to 2. Show the work that leads to your answer. Guys, this feels like a net change. Net change. Let me just write my equations down because we're gonna have to go to this in a second, and then I'll bring you guys to my iPad. So we know we're looking at particle J. So we know the velocity is equal to 2t t squared minus 1 cubed. We know that the position at 0 is equal to 7. And then we need to find the position at 2. Guys, let's go. This is what we're doing. Net change. Because we already have the velocity. In other words, we have the derivative of position. And we know something about the position, and that's t is equal to 0. When t is equal to 0, the position is 7. So we're going to do net change. We're going to do the integral from 0 to 2 of the velocity of j with respect to time, with some disrespect to t. That's what it is. Because this is going to equal to the position at 2 minus the position at 0, according to the first fundamental theorem of calculus. Okay? If I were to add this, the position at 0 to the other side, because that's the one we know that's equal to 7, we would have the position at 0 plus the integral from 0 to 2 of the velocity dt is equal to the position at 2, which is actually what we're trying to find. So what we now have, we have h of 0, or x h of 0, the position at 0, is 7. We have 7 plus 0 to 2, and then of the velocity. So now we have to write this down. Okay, 2t, t squared minus 1 cubed dt. All right, and this is equal to the position at 2. All right, you're probably ahead of me, but I'm going to race you. I'm going to quickly do this, okay? So u is equal to t squared minus 1. du is equal to 2t. Ooh, let's go. So when t is equal to 0, when t is equal to 0, u is equal to 0. When t is equal to 2, u is equal to 1. I just changed my variables there. So then now what we have is we have 7 plus, and then we have the integral from 0 to 1 of the 2t cancel out because that's our du, u cubed du. And then so we have 7 plus u to the 4th, not u to the 7th, oh my gosh, u to the 4th over 4 from 0 to 1, 7 plus 1/4. And then we can just actually leave it like this. This is our position. Non-calculator portion. Yeah, this is a non-calculator portion. Did you beat me? Gosh, it's so hard when you're flipping. When I have to like double tap my my Apple Pencil so I could erase things. So no one's. Someone say you're getting twos. No, don't say that. So the only rules that you should probably know for substitution, or like when it comes to integration, is literally use substitution. Okay. If you need to review that, definitely go to like on YouTube. Black Pen Red Pen is incredible. He has a bunch of different videos on that. But guys, at this point, the U sub kind of got you. I totally forgot there was a U sub. I remember covering this with a student last year who got a 5, by the way. Oh God, that U sub. Whew. Oh my gosh, that was fun, huh? That was real fun. Okay. Just so you guys know, I'm just gonna put you here. I'm gonna answer some questions from Discord. Let's see what we can do. Let's see. Yes, sir. Yes, sir. Okay. Let's do another FRQ. Oh boy, we haven't done a table analysis. Should we do one of those? That's like the Riemann sum. Can we do that? Yeah, I think we should find one. Give me let me just find one real quick, and then we'll be good to go. I'm gonna go to my Google Drive, and then I'm gonna pull it up. Apparently it takes a lot of bandwidth, so I'll pull it up, and then I will show it to you guys. Someone's asking if I do private tutoring. That's technically what my essential business was in the very beginning before I realized that social media can take over. Um, so I will say I tutor maybe 12 students a week when I used to tutor like 35. Yeah, the trapezoid sums. What we're gonna do is I'm just gonna pull up one and then we can do like let's do left, let's do right, let's do trapezoid. Let's kind of see how that works. Um, let's see. I have a 2020. No, no, no. I'm gonna pull up like a random one. Give me a second. Okay, hang with me. If I hope things might slow down, but just give me a second. I'm gonna pull up the problem. I'm gonna take a screenshot of it, or I'm gonna save it, and then we'll be good to go. Uh, let's go to the tables. A second, guys. 1 second. I slow down. Here we go. Question 3. I don't know if this was a calculator portion. Like it. We're gonna assume that this is a non-calculator portion. I'm gonna take a picture of this. Got it. Second. This is question 3 from what year? I have no clue. But let's save this. Let me cancel this. Let me put it on here. I'm gonna put it on Discord. And then I'll pull this. All right, guys. We are back. We are back. We are so back. Okay. So here's what we have. This is question 3 from God knows what year. It's I really don't know what it is. If someone knows it, let me know. Yeah. Yeah. Before we even start, someone said I never learned optimization. The only thing you have to know about optimization is when do you have a minimum or a maximum. So it's not going to be the types of optimization problems that everyone talks about. You don't have to stress about it, in my opinion. Okay, don't race me on this one. Not yet. I'll let you know when you can race me. Okay, but again, pull out your pen and your paper. Start try to work things out on your own. But let's see what we have. We have a table, and it looks like distance 0 to 100, 193. Great. We read that. Awesome. A metal wire of length 8 centimeters is heated on at one end. The table above gives selected values of the temperature in degrees of the wire X from the heated end. The function T is decreasing and twice differentiable. Keep that in mind. The reason why they say these things is because one, it's decreasing. So just it's decreasing. Okay, we can kind of picture that. But the fact that it's twice differentiable just means we can take the derivative 2 times, but also it is continuous. That's the important thing. This function is continuous. Okay. So this is a great question. Estimate t prime of 7. So estimate the derivative of the function at 7. Actually, this is... Oh, actually, no, we can do. This is great. I'm actually glad they gave you this problem. Let me first draw up the table on my iPad, and then I'll bring you guys there. X, we have t of x, 0, 100, and then 193. Guys, there's just a joy in like knowing these types of problems, right? Like what a treat to take a calculus AB or calculus BZ. What a joy. I mean, what a rite of passage. Think about it. Not many people take this exam. It's something that not many people take. Calculus is something that people think is super scary, but what a joy that you're here and being able to like take these exams and review for it. It's just a privilege, I would say. It's a privilege. Okay, so they want us to estimate t prime of 7. I love this question. Actually, this might be a question that was given to me when I took this exam. I don't know. But the whole point is we need to take the derivative at 7. We don't know shit about the function. We really don't. 2005 AB. Wow, that's awesome. I took it in 2007, so I guess it wasn't it. Hey, Crazy Run. So let's talk about this. We don't know anything about the function, but this is why they do this. 7 is between 6 and 8. We're estimating. So what we can do is we can take t of 6 or t of 8 minus t of 6. We can do t of 6 minus t of 8 if you want that, over 8 minus 6. Because this is just an estimate. Okay? And then we're going to talk about the unit to measure in a second. Now, on the top, just keep in mind we have degrees Celsius over distance or over centimeters. So our measure or our units are going to be degrees Celsius over centimeters. Okay, so T of 8, we know is 55. It's literally on the table. That's the y value when x is equal to 8. Okay, so 55 minus 62 over, and then 8 minus 6, which is going to be 2. So let's just simplify this. So 55 minus 62, that's going to be negative 13 over 2. I hope I did my math right on that one, right? Yeah. Okay, negative 13 over 2, and then we'll do degrees Celsius over centimeters. It's going to be important that we do this proper units. One, we showed our work, but also notice that the y values were in terms of degrees Celsius. This was on the table originally, and then we have centimeters for that. Yes, so this is common. Estimate this. Boom, we found it. Again, this is 2005. Haven't seen T prime of 7 or like where you have to do this in a while, but you know that's a common. And then someone's asking to do like an IVT, MVT. Just wait for part D. Okay, so here we go. Part B tells you to write an integral expression in terms of T of X for the average temperature of the wire. Estimate the average temperature of the wire using trapezoidal sums with 4 subintervals indicated by the data in the table. Indicate units of measure. I love this one. Why? 2 things. 1, it's trapezoids. Fuck yeah. 2, it's you cannot use the rule or the common trapezoid like formula that you know. So in this case, you have to really wait. 13, did I get that wrong? 55 minus 62? Bro, like did I not? Thank you. Thank you. Thank you. It's negative 7. What the fuck am I doing, guys? Negative 7 over 2. Wow. This is like, can you believe what would happen? There, I changed it, by the way. That would suck if you did your math right. Wow. There you go. Well, this will be negative 13. Go with spam negative 13 in the Discord chat for sure at this point, because my goodness, that was terrible. Oh, sorry. There we go. Negative 7. I'm sorry, guys. I'm sorry. Oh, that was embarrassing. This is what happens, man. Yeah. Seriously, what am I doing? But anyway, okay, let's talk about this. Trapezoid rule. Now, here's the thing. Let me just draw this very quickly. I guess I could just draw it in here. Maybe I can make this a little smaller. Okay. So 0, 1, 5. So it's kind of stretches, and then it's 6, and then it's 8. So here's the thing. You guys, you cannot use the typical like a formula that everyone likes to use for trapezoids because like, oh, I can just learn the formula. But in this case, we have to remember how to do a trapezoid. Yeah, I agree. That's why you leave it as 55 minus 62 over 2, because you can do stupid shit like me. Negative 6. Wow. Wow. Oh my God. All right, let's continue. So this is going to be 0 is 100. I'm just going to draw this. I want you to kind of look at what's going on. So we have 93, and then we have 70, which is going to be a little lower. 70 is up here. Then we have 62, and then 55. Because 62 minus 55 is equal to 13, guys. Negative 13. Okay. So let's just assume that the function looks like this. All right. It wants to do trapezoids. So again, we have to do the average value. Remember, the average value is 1 over b minus a, integral from a to b of whatever function we're looking at. So this is 1 over 8 minus 0, because they want to find the integral with 4 subintervals by the data. Okay, yep, the integral. 1 over 8 minus 0 of the integral from 0 to 8 of t of x dx. Okay, so this is going to be 1/8 of something. So we have 1/8 equals. So let's talk about this real quick. All right. Now 1/8 equals, we're going to have 1/8. And I think I'm just going to leave my answer like how I'm going to write it, and then I'm going to be done. Okay. Going back to our problem, don't forget, we're doing trapezoids, but they're not of equal length every single time. Now remember, the area of a trapezoid is 1/2 base 1 plus base 2 times the height. But the thing about this is you have to remember base 1 is technically the height on the left, base 2 is the height on the right, and the h is the width. Okay? So for the first trapezoid, we have 1/2 height or base 1 of 100 plus the next one is 93 times the width is 1. That's your first trapezoid. Then we go to the next one, which is this one that I'm drawing up. So notice that this has a width of 3. So this is 1/2 base 1, which is going to be 93 plus 70 times, and then this is going to be 3. And then I'll continue. 1/2 times, don't forget the next trapezoid is this one. So we have base, so we have 70 plus 62 times the width, which is just 1 plus 1/2. And then I'll just finish it up, 62 plus 55 times, and then the width is going to be 2. And I'm just going to leave it like this. I'm not even going to simplify that. I'm going to leave it like this because I know I'll mess it up. How did I get negative 13? Oh, I'm still looking at this like, what did I do, guys? Oh my goodness. All right, time for a Coke Zero. Or maybe not. It should be punishment. Time for some push-ups. 10 push-ups? No. Second height is 4. I did thank you. That's what happens. Thank you. So this second height, this one right here, this was originally a 3. The width right here is 4. Like, this is crazy. Like, just imagine like you know, I don't know, someone is you're playing a basketball game, you're doing everything great, but I don't know, you just can't you I don't know, I can't even compare it to anything. Yeah. Thank you. 13 push-ups. 13 push-ups. Give me a second. There. 13 push-ups. Just for you. I hope Seattle gets an NBA team. All right, let's continue, shall we? Oh my gosh, I can't believe I missed that. Let's go to part C. So we have find the integral from 0 to 8 of t prime of x dx and indicate, sorry, I'm reading the chat here. 4 more for what? 4 more? Oh, all right, I guess you're right. 4 more. Every time I get an algebra problem wrong, 4 more. Oh, you guys are ridiculous. You guys are ridiculous. All right, let's do this. So we're trying to find the integral from 0 to 8 of t prime of x dx, okay? And indicate units of measure. Explain the meaning of this, right, in terms of temperature of the wire. Well, let's go back to the blackboard. Integral from 0 to 8 of t prime of x dx is equal to, according to the first fundamental theorem of calculus, t of 8 minus t of 0. Okay, I'll answer some questions in a second. No. All you guys are crazy. All right, so we know some values. Remember, according to the first fundamental theorem of calculus, this is equal to t of 8 minus t of 0. So t of 8 is literally 55 minus t of 0 is going to be 100. So we do 55 minus 100. I'm not simplifying that. We're done. I'm not simplifying that. Okay, so we'll leave it like this. But remember, this is degrees Celsius. Whoops, I guess we can just do degrees Celsius. So they're asking like, what does this mean? Well, back to this. In terms of the temperature of the change, well, this is the rate of change. So we can say that the total change in temperature between 0 to 8 centimeters is going to be this value, 55 minus 100. So we'll have to write that. So we say change in temperature from 0 centimeters to 8 centimeters is negative 45 degrees Celsius. I got it right. So screw you. I got it right. I got it right. You can't say that. I got it right. Okay. So let's continue with part D. Are the data in the table consistent with the assertion that the second derivative is greater than 0 for every x on the interval 0 to 8? So what do we say? This is interesting. So they're saying, is the data in the table consistent with the assertion that t double prime of x is greater than 0 for every value of x on the interval from 0 to 8? Well, the function is decreasing. We know that, right? Second derivative. Second derivative. You guys are fucking wild. I love this. I love you guys. This is so. These are memories that we're building. This is the best. Okay, but let's talk about part D. Is the data in the table consistent with the assertion that t double prime of x is greater than or equal to 0? I'm assuming that's t double prime. I don't know if I can zoom in on that. Yeah, that's. It looks like it is. The second derivative is greater than 0. Well, let's see. The function is continuous. We know it's decreasing, so I guess we can say, well, let's see. For part D, the function's continuous. We know the function is decreasing. So is it possible that we know the function is decreasing? I feel like this is correct. But what about it? Yeah, thank you. Jake said, like, I love the way you wrote that. Well, let's see. I don't know. This is my guess. Okay, this is the way I would write it, because someone said t prime of 7 is going to be what did we find for t prime of 7? Let's go to my blackboard over here. T prime of 7 was negative. So is it possible if we took the derivative, like it's a change, this will be like negative 7. So I'm looking at the table, and then this is also changing, right? Can we say that it's, yeah, right? It's like negative 17 over 4. So it looks like everything is, gosh, to be honest, I don't even know. This is negative 8 over 1, and then negative 7 over 2. So the whole point, if you notice that this value is changing. Yeah, guys, how would you do part B? I think this is 2005, someone said. Yeah, so we can see changes in negative 7, negative 12. So then, but then that wouldn't. Someone did say MVT. So is there a possibility that the second derivative is changing? So we'll have to kind of do some. Here, let me just erase this. So this is the part of a part D. Okay, let me just erase all this, since we kind of already know. So what I'm going to do is I'm just going to write, like, I'm going to estimate some values. I think that's what I would do. And then I would do MVT. If we use MVT on 1 to 5, we get negative 5.7. But MVT is, but this is, the problem with this is that this is t prime of x. This isn't t double prime of x. MVT on the interval from 5 to 6 is -8. Yeah, so someone said MVT. Yeah, I don't know if so the thing about this is we know that it's decreasing, so we can say T prime of X is less than 0 all the time. We can say it's decreasing. But the thing about this is we're trying to show the second derivative. So I guess we can say T double prime of X is equal to T double prime of B minus T double prime of A over B minus A. Let's just say, for example. Okay. Now, the function is decreasing. So that must mean that, for example, if it is decreasing, yeah, T double prime is not going to be positive, because the way I see it is if this is decreasing, so T double prime of X will always be negative. So you have like a negative term, like T double prime of B minus T double prime of A will also be negative. And then B minus A would just be positive. So T double prime of X is less than 0. That will be my guess, to be honest. I'm gonna look at the answer for this in a second. Okay. Because again, the only thing that we said, if we look back at our problem, was that the function is decreasing and twice differentiable. So if t is decreasing, we know that this derivative is less than 0. So let's see what the answer was for this. Okay. So let me just open this up. I have to open up my Google Drive. Give me a gosh, guys, I literally lost the answer to the. Yeah, we can totally graph this, but again, I don't know. What do you guys think? Should we kind of move on, or should we try to tackle this one? We can talk about it on the Discord. It seems like a lot of people are talking about it. Yeah. So answer key uses MVT. I think it's the best way to say it. I completely agree. So I think for this one, it has to be somewhere along the lines of, well, we know that T prime of X is less than 0 every single time. And it's decreasing every single time. So it's negative. So I guess my guess will be that this will be negative, because again, I'm doing T double prime of X. I'm basically using MVT. So I'm assuming T prime of X is continuous on, let's just say, for example, 0, 8. T prime of X is diffable you write that on 0, 8. And since T prime of X is less than 0, then T double prime of X, which is less than or equal to, or is equal to T prime of B minus T prime of A over B minus A, is less than 0. So we will say by MVT, T double prime of X is not greater than 0, somewhere along those lines. Well, I guess we can. The thing is, we don't know F prime. Someone was just commenting if we can graph F prime. But that will be my guess. To be honest, this reminds me, and I'm going to tell you guys something right now. Typically on the AP exam, you guys, which is going to be interesting, you guys are going to come out of a certain problem, and you guys are going to ask, like, what did everyone get for part D? What did everyone get for this particular problem? And what's going to happen is that's going to be the one discussion of the entire exam that people were basing their answers or had contrasting answers. And typically even like the College Board will kind of like address it and they'll be like, yeah, that one was kind of hard. So this This was something. This was something, or that would have been the problem. Okay, we did rate of change, or we did a velocity problem. We did a table. Oh, one thing that we didn't do was Riemann left Riemanns, but I feel like we kind of like understand that. So let's just kind of move on from that one just for now, just because I definitely want to touch on other problems. Oh, here's one that can easily show up. Let me go ahead and go to the slideshow. Okay. What we have here, guys, is obviously a graphing calculator. Is we have for time 0 to 6, a particle is moving along the x-axis, and the particle's position is not explicitly given. But the velocity of the particle, v of t, is equal to this function. The acceleration of the particle is given by a of t, 1/2, all that stuff. And then they tell you that the position is equal to 2. So the position at time is equal to 0 is equal to 2. So we got to find, is the speed of the particle increasing or decreasing at time is equal to 55 or 5.5, not 55. Okay, no more push-ups for me. So let me just write some stuff down. Well, I guess we have v of t, we have a of t. I'm going to write all those things down in a second. We have x sub 0 is equal to 2 sine of e to the t over 4 plus 1/2 e to the t over 4 cosine of e to the t over 4 plus 2. Yeah, I agree. This is pretty easy. I mean, this will be the first problem. And hopefully if you saw this, you're like, okay, I got this. Easy work. Because is the speed of the particle increasing or decreasing? Well, the first thing that we got to do is we got to find v of 5.5 and a of 5.5. Because if this will tell us the acceleration, this will tell us whether it's positive or negative, and that's really the important part. Okay? So let's go back to our problem. Let's go to Desmos real quick. Let me just close these. And let's go to Desmos. I'm just going to finally erase these things, and then we can just write our function. V of t is equal to, and I think it was 2 sine of e to the power of, maybe I should do x over 4. I'm actually going to change it in a second, because Desmos doesn't like when you put in terms of t. So I'm just going to put x. That's one of the important things you kind of have to remember. And this is plus 1. And then I have a of x, which is equal to 1/2. And then this is going to be e to the x over 4. Whoops. And then we have cosine of e to the x over 4. And then we have plus 2. Yeah, I'm just going to double check that that is correct. Looks like it is. Well, all we have to do now is plug in 5.5. So v of 5.5 is equal to negative 0.45. A of 5.5 is equal to 0.46. So v of, I'm just going to put, since v of 5.5 is less than 0 and a of 5.5 is greater than 0, I'm going to go back to my iPad here. The particle is slowing down. That's it, guys. Because again, going back to the problem, although we're asking whether the speed is increasing or decreasing. So I said particle is slowing down, but I guess we should say the speed is decreasing. Because remember, if it's the same sign, then it's increasing. If it's the opposite sign for both the acceleration and velocity, then it is decreasing. All right? So that's what we got to keep in mind. Let me go back over here. So maybe I should have said speed is decreasing because they were asking. Okay, so now for part B is to find the average velocity of the particle from the period 0 to 6. Average velocity. This is where a lot of people, for some reason, they might get this wrong just because they start doing something else, but this is average velocity. So this very much reminds me of average value. So remember, average velocity, in other words, average value is equal to 1 over b minus a, integral from a to b of the velocity dt. So in this case, for part B, they're asking for the average velocity from 0 to 6. So this will be 1 over 6 minus 0, integral from 0 to 6 of v of t dt. And we would just go and to our Desmos or our graph, and we would just graph that. So let me just do that now. So I would do 1 over 6 int, don't forget that's how you get your integral, to 6 of v of x. We have to do v of x, and then we have dx. So we have 1.949. Again, you can truncate it, you can simplify, or you can round it to 3 decimal places, but I believe it has to be 3 decimal places. Someone said do not confuse average velocity with average speed, because I believe average velocity is what I just wrote. Average speed would just be the rate of change, or the slope between the position, right? Jake, please correct me if I'm wrong there. Oh, I like that. It's best to put integral from b minus a. But yeah, that's going to be part B. Now, find the total distance traveled by the particle from time t is equal to 0 to 6. So let me just write this down. So total distance, 0 to 6. Okay, here's my final answer. Total distance is equal to the integral from 0 to 6 of v of t dt. This is totally, I got this right. I totally got this right. I know I got this right. Total distance, right? Let me see what people are saying in the chat. I don't know if people are saying that. If I got that right. This is wrong. This is not total distance. This is total displacement. Total distance, again, what we have to do, total distance is the integral from 0 to 6 of the absolute value, okay, of dt. This is total distance. So you gotta know the difference between those two. So if they say total displacement, then we do the first integral, but we have to do total distance. You know who? I love that they're going on Discord instead to type that. But yes, thank you so much. Got you guys. Got you. No push was for me. I knew exactly what I was doing there. Okay. So I've got to go back to my problem over here. And I just got to take the velocity, or the not 1 over 6, integral from 0 to 6 of the velocity function. And I got to make sure, but by the way, I just want to make sure that I wrote the problem correct. Got to put the absolute value signs. Got to close that. Got to close that there. Whoops. There it is. This will be my total distance traveled. 12.573. Okay. If you do the integral from 0 to 6, then that will be then that would not be good. Okay. That would not be good. So you have to take the absolute value. Yes. Thank you. A lot of people said, don't forget your total distance. Total distance is the absolute value of the velocity, or the integral of the absolute value, and total distance, or total displacement, I'm sorry, is going to be just the integral. Okay, so part D. For 0 to 6, the particle changes direction only once. Find the position of that particle of that time, or find the position of the particle at that time. Okay, so for D, the particle changes direction exactly once. Find the position of that particle at that time. So first we got to find when it changes position. Okay, and when does it change position? When the velocity is equal to 0. So the first thing we got to do is find when the velocity is equal to 0. Well, let's just go ahead and go to our function over here. A position. So if I kind of erase everything here, we're just looking at the velocity, and it happens between 0 and 6. It happens at 5.195. Okay. So 5.195. T is equal to 5.195. I graphed it over here. Sorry, I was looking at the graph and I wasn't even showing you guys that. Yep. So when v is equal to 0, there it is, 5.195. So now all we have to do is we need to find the position at that time. So find x of 5.195. But how did we do that? Scribbles, how do we do that? Because according to our function, we don't have the position function. We'll have to integrate this ugly looking thing, which, by the way, don't even try to do u sub. But this is why they give you this. When we have the velocity, they give you something about the position, which we know at time 0 is equal to 2. So we're going to use net change. So let me bring you guys back to the iPad here. We need to do integral from 0 to 5.195 of the velocity. And that's going to equal to the position at 5.195, which is what we're trying to find, minus x of 0, which we know it to be 2. So I'm just going to bring that to the other side. 2 plus integral from 0 to 5.195 of the velocity is equal to x of 5.195. So all we have to do now is find the value of the integral that we have there. So let's go back over here. Jesus, someone already beat me to it. Who the fuck is that? Someone on Discord already beat me to it. I'm seeing that result. Crazy. You guys are diabolical. 5.195. No push-ups, though. No push-ups. V of x dx. It's 12.134 plus the 2 is going to be 14.134. That's going to be the position. Okay, using net change. Let me bring you guys back to the iPad, and here we go. Someone is asking if it's worth relearning the optimization problems. No. To be honest, the only optimization that you guys have to know is when do we have a maximum, when do we have a minimum, and justify that. You can do that by the second derivative test, or you can quite literally just do that by doing a number line test and show, like, it changes signs. That's all you have to do, okay? Just keep that in mind. Nothing crazy. Oh, okay. We're going to do another problem, but does anyone need a break? Are we good? Does anyone need to use the restroom? If you do that, go grab a drink if you need to. I still have my Coke Zero with me. I have my tea. I have my LaCroix. But yeah, this is fun, guys. Let's continue with the chat and let's see what we got. Again, I'm going on Discord just because that's where people are posting their problems. So let's see what happens. Damn, you guys are so good on Discord with the chat over here. You guys are amazing. We did a problem like this similar to yesterday. What haven't we done? Can we look at the predictions? Do you guys have should we do like an MCQ problem? Maybe perhaps those will be good. What do you guys think? MCQs. So link to the Discord. Keep looking at the comments, or in someone link it. Oh, if not, I'll just do that real quick. Okay, let me answer some questions because I feel like people are asking. But let me find the I'll do the invite link here. Okay. Okay, implicit differentiation, and then I want to do series, but I kind of want to know. Okay, I'm gonna do some MCQs, but I kind of want to know integrals. We'll do integrals later on. Oh, I cannot wait. Okay, we should do some. We did an implicit differentiation problem. Could do that. Gosh, how many of you guys are here from BC? Like, maybe I should do a poll. Let me let's see if I can do a poll, because I think I can't do polls in here. That's insane. Maybe I'm not allowed to. Wait, hold on. Give me 1 second. Maybe I can do this on this side. I really hope I can. Maybe I can do it on my desktop. I'm gonna see if I can do a poll. I want to know how many of you guys are on BC and or AB, and then we can that. Okay, here we go. Or BC. Yeah. Comment. Oh my gosh. Okay. AB, AB. Oh my god. Okay, I'm gonna try to do some series. Maybe at the end. Okay. Apparently I posted it. Damn, I don't think it works on mobile. All right, let's pull out some MCQs. Give me a second. Let me go ahead and pull out the um it's crazy that this is, I think, let's go ahead and do some problems on here. Let's get to it. Okay. All right. There's going to be some questions when we're like, guys, I don't think we have to do this, in my opinion. But if I skip something and people are like, no, please do this, then we'll do that. But for now, again, I want to stick with AB just because there's a lot of people just doing AB. Well, the moment I do BC, the majority of the people will get a little lost. So I wish I should have done a BC stream. I'll try to do that maybe tomorrow, but it's tough. But okay, let's go to number 1. We're gonna speed run through this stuff. Okay, so again, the whole point is we're just having a relaxed session, and we're trying to solve these very quickly. So let's see. No one beat me on this. I'm gonna be so pissed. I swear, if you post in the Discord with your solution, I'm gonna be so upset. Okay, so here we go. We have to solve this problem. It's just a simple chain rule. We bring the 7, 2x squared plus 5, okay? And then times the derivative of what's inside. So we're going to do 4x. So this will be 28x, 2x squared plus 5. And I made a little mistake. This should have been to the power of 6. We have to the power of 6. There we go. So 28x to the power of 6. D. Easy, easy, easy. Okay. Oh my goodness. We have an integral. A very basic integral. Okay. I'm writing the problem down real quick as we do this. Well, you can do u sub. I'm actually going to show you guys 3x plus 12 du is equal to 3 dx. So 1/3 du is equal to dx. So now what we have is we have 1/3 integral of 1 over u du, which is 1/3 natural log of u plus your cheese, or 1/3 natural log of 3x plus 12 plus your cheese, and that will be our solution. The good thing is that if we go to our slideshow, I keep saying slideshow. The hell did I do? This is interesting. Wait, did I do something? Wait, did I genuinely, did I miss something? I guess the only thing, notice that I got my solution, which was technically right, but there's an issue here. If I go back to the problem, notice that my answer wasn't on there. And the reason for that, it's like, oh shoot, they factored out a 3 from here. So they made it 1/3 from the very beginning and made it 1 over x plus 4 dx. And then now we can just get 1/3 natural log of x plus 4 plus c. So that should be our answer. What in the world did I do incorrect on that one? Crazy. So our solution should be, it looks like it's going to be B. Damn, this is nuts. Wait. No. I'm not, push-ups? How many? 3 technically, because I didn't factor out the 3. Only 3. That's it. Only 3. You guys only get 3. 3. I tried to do a one-handed one. Oh. All right. Let's move on. Who said 3 times 4? No. I'm not doing that. Okay. Here we have a function here where we have to take the derivative. I think we can do the entire MCQ, to be honest. F of x is equal to 5 minus x over x cubed plus 12. Okay, quotient rule, here we go. Okay, f prime, low d high, which is -1, minus high d low, which is going to be 3x squared, over low. Okay, so then we have -x cubed minus 2, minus 15x squared plus 3x cubed. So I'm just doing the numerator right now. 2x cubed minus 15x squared minus 2 over x squared, or x cubed plus 2 squared. That should be an x cubed. So let's see. I'm looking for a 2x cubed minus 15x squared minus 2, and that looks like it is C. Yeah, let's just speed run some MCQs. Again, I feel like we've done a lot of FRQs. Let's just kind of go through these and then see what we can do. I think that'll be fun. Number 4. Ooh, the table above gives the velocity in miles per hour of the truck using a trapezoidal sum of 3 sub-intervals by the table. What is the approximate distance in miles? Okay, the approximate distance in miles the truck traveled from 0 to 3. Well, I think this will be a good time to do left, right, and then let's talk about trapezoid. So I'm just going to go ahead and do my table. This is 0 to 20, 0.5 to 60, 0.5 to 60, 2 to 40, and then 3 to 30. Okay. So if we're doing a trapezoid, don't forget, the first one is going to be, we're not doing average value. So it's from 0 to 3. So we have to do 3 sub-intervals. And don't forget, for a trap, the trap house, we're doing 1/2 base 1, 20 plus 60 times 0.5 plus 1/2 base 1, 40 plus 40, or 60 plus 40 times, 1.5. Geez. Okay, 3/2. And then plus 1/2. 40 plus 30, and then that's going to be times 1. If we could simplify this. I don't know if this is the calculator portion, but we will go. Yeah, things will get harder. All right. So in this case, we can just do that. Now, let's just say they did an RRAM. They did a RRAM problem. Then we will do 0.5 times 60. Because we're looking at this interval, we're finding the width, which is 0.5, and then the height is going to be based off the right-hand side, or the right value. Plus, and then we do 1.5 times 40, okay, plus 1 times 30. Okay, and if we do LRAM, then we do 0.5 times 20, because once again, you're looking at that first 2 intervals. You're doing the width is 0.5, but then the height is going to be determined by the left endpoint. Plus 1.5 times 60 plus 1 times 40. I just kind of wanted to give you guys a different situation for this. Okay. All right. Let's continue. So the derivative of this, guys, at this point, I'm going to assume you know how to take this derivative. If you guys have questions with this one, okay. Yes, RRAM means right Riemann sums. LRAM means left Riemann sums, okay. For number 5, I trust that we know how to take derivatives. We're going to skip this one. I'm hoping that that's okay with you guys. If you have questions, definitely go to the Discord and ask those questions, because I mean, it's quite common that some people might not understand that. Okay, for number 6, if f is a function given by f of x, then the average rate of change of f on the closed interval. Common question. Average rate of change. Remember, average rate of change is the slope between those two values. So what we're trying to find, I'm going to show you guys in a second, is the rate of change, f of b minus f of a, over b minus a, which is equal to f of 5 minus f of 1 over 5 minus 1. Now, f of x was equal to 3x squared minus x cubed. So that means that f of 5 is 3 times 5 squared minus 5 cubed. So we have 3 times 25, so 75 minus 125, which is negative 50. And then f of 1 is 3 times 1 minus 1 cubed, so 2. So our rate of change, or the average rate of change, will be f of 5, which is negative 50, minus f of 1, which is 2, over 4. So we will get negative 52 over 4, which will be negative 13. And if we look at our answer, negative 13. That's it. Here we go. Let's go to number 7. So we have the integral from 4 to negative 10 of g of x, and that's equal to negative 3. So let me just start writing that down because it looks like we're going to need that information. 4 to negative 10 is equal to negative 3. And then we're given that 4 to 6 of g of x is equal to 5. So then we got to find the integral from negative 10 to 6 of g of x dx is equal to. That's what we're trying to find. Okay. For some reason, I'm confused. I don't know why. I'm like, wait, do I even know how to solve this problem? Maybe I do. Well, the idea is that the whole thing, let's just say this is negative 10. I want you guys to kind of look at or see what's going on here. We have a function. The area of the entire thing from negative 10 or from 4 to negative 10 is negative 3. So I guess we can say this area is going to be 3. It's going to be positive. I want you to think about why that's positive. And then they tell you that the area from 4 to 6 is going to be 5. So then they want us to find the area from negative 10 to 6. Well, the area should be 8. Now, the reason for that is because what we want is we want the area from negative 10 to 4 of g of x plus the area from 4 to 6 of g of x. But the thing that they trick you on is this value. Now, we know that the other integral was equal to negative 3. But if we switch the signs and make it negative 10 to 4, then it's just the negative counterpart of our value. So that's why we got 3 and then plus 5. And then the answer is going to be 8. Easy. Easy. All right. Number 8. Okay, if the function f is given by this, which of the following is an equation of the line tangent to the graph at those points? So I'm just going to start writing it down. Now remember, the equation of the tangent line, well, that's the x minus or y minus y sub 1 is equal to m times x minus x sub 1. All right, we have the coordinates 3 natural log of 4 comma 4. So what we have to do is, since we already know those values, and I think the answer right away is just going to be d, just because, or what am I saying? No, it's not going to be d. That will be wrong. It's either a, b, or c. Because d is assuming that your y sub 1 is 3 natural log of 4, and that's not the case. So let's go ahead and bring you guys to my iPad here. We have y minus 4, and then we're going to take the derivative in a second, x minus 3 natural log of 4. Okay, we need to just take the derivative of this. F prime is equal to 1/3 e to the x third by chain rule. Plug in your 3 natural log of 4, and we have 1/3 e to the 3 natural log of 4 over 3. So the 3's cancel out on top. The e and the natural log go away. So this is just 4/3. So we have y minus 4 is equal to 4/3 x minus 3 natural log of 4. And that's just going to be a. Okay. We can do, actually, that will be a good idea. Let's do some BCMCQs. I feel like that will be really good. Okay. The reason why I'm saying that is because if something's, I'll do the BCMCQs when it's a calculator portion. Okay. Once we finish this non-calculator, we'll do a calculator portion and we'll do that. Let's just finish this off because this is also for BC. So we have a function with the graph. Okay. And our function is f of x. So the graph is shown. Which of the following expresses the relationship between the integral from 0 to 2? So notice that all these here are just inequalities. Okay. So some are positive, some are negative. Well, what we can say is the area from 0 to 2 is going to be positive. It's just above the x-axis. And the area from 2 to 3 is going to be negative. So in fact, one of the things that we should already look at is C or D are going to be the correct answers. And then I think the next one, notice that if we look at the options, we either have in the middle, it's the area from 0 to 2, which is a positive value, but the other option has the area from 0 to 3. Now, you have something that's way positive on the top, and then when you subtract it by, or when you add something that's negative, you're going to just shrink it a little bit. So that must mean that that is less than the top function, the top area. So our answer in this particular case is going to be D. That's it. Okay. Don't worry, you can go to sleep. This live is here for to stay. So you can definitely do this later on. Ooh, okay, you sub. No one beat me to it. Actually, I'll race you to it. You can start writing it down. Integral from 0 to 2, x cubed plus 1, and then we have to the 1/2 x squared dx. So let's go to our problem over here. U is equal to x cubed plus 1, du is equal to 3x squared dx. When x is equal to 0, u is equal to 1. When x is equal to 2, u is equal to 9. So we have the integral of 1/3, 0 or 1 to 9 of u to the 1/2 du. And then so we have 1/3, we have u to the 3/2 times 2/3 from 1 to 9. So we have 1/3. Actually, let's take out the 2/3. So 2/9. And then we have 9 to the 3/2 minus 1 to the 3/2. Now, 2/9. 9 to the 3/2 is square root of 9 is 3. So cube it, 27 minus 1. So then we got 2 over 9 times 26. So hopefully we get an answer of 52 over 9. Whew, who beat me? Who beat me? The answer is A. I believe this is a public test. Okay, here we go. Implicit differentiation, number 11. So we got a function. We got x squared plus x y minus 3y is equal to 3. And we need to find dy dx at 2, 1. Am I too quick? Okay, I'll take my time. So let's see. They want us to take the derivative of this. Let's see. We're going to take our derivative. So the very first thing is 2x plus. Now we're going to go ahead and apply a product rule. So we have x times the derivative of y, which is 1 dy dx, plus the derivative of x, which is 1 times y, minus 3, and then the derivative of y, which is dy dx, is equal to 0, because we also have to take the derivative of the other side. So now we can just go ahead and plug in a 1. We're trying to solve for dy over dx. So now we're going to go ahead and do 2, 1. Okay, so we have 2 times 2 plus 2 dy dx plus 1 minus 3 dy dx is equal to 0. So if we simplify this, let's see, we have the 4 and the 1. That looks like it's 5 plus, and then we can combine these two. 2 minus 3, so minus, I'm just going to put minus dy over dx is equal to 0. So 5 is equal to dy over dx. That will be our solution. If we go back to our problem, you'll notice that this is option A. Okay. Not bad. Implicit differentiation. Let's go to number 12. The number of gallons in a storage tank at time t in minutes is modeled by this function. Okay, the number of gallons. At what rate is the gallons per minute? Or the gallons in at what rate in gallons per minute is the amount of water in the tank changing at time t is equal to 3? So they're saying at what rate? I'm already thinking, well, what's the derivative at this point? So for number 12, w of t is equal to 25 minus t squared. Let's take our derivative, and we're just going to plug in 3. Okay? we're taking the derivative, which is negative 2t, and then plug in 3, negative 6. That's it. That's it. Okay? Rate of change. At what rate is something changing? You should think derivative. Ah, a slow field problem. Ooh, this one's nice. Okay, this is actually a good opportunity for us to talk about slow field. And maybe we can later on, if someone has a slope field, someone have a slope field problem, we can definitely do that. We can do a problem like that for sure. Or a slope field FRQ, sorry. Someone's already talking about D. This is crazy. I wonder how they got that. All right. So one of the things that you should probably look at in this particular case is notice, like, if there's any, when especially when the slopes are undefined or when it's 0. So if you notice up on top, when y is equal to 4 at any given time, the derivative is 0. So that must mean that when y is equal to 4 for any of the values, which you'll notice over here, it looks like all of them are going to be those correct answers. Okay, so we can't really do much with that. Okay. So let's see. I guess we have to look at other values. So if you notice that, let's see, above the x-axis. So the moment we get above the x-axis, okay, or above the x-axis, the slopes are positive. And then you get to 4, the slope is 0. But then you get to above 4, any value above 4, the slope is now negative. Well, I guess that's kind of going to be the same type of problem. Oh my goodness. Yeah, so I'm okay. So I guess I kind of have to, what I would do now at this particular point. Wow. I'm curious what these the values are going to be. Everything's being divided by 4. So I'm actually going to look at, let's just say I said everything was positive and now it's negative, so it doesn't look like none of these will really help me. Except I guess we could eliminate. So at this point, you kind of have to look at some points. So look at let's just say 2 comma 2. It looks like we're gonna have a slope of 1. So we're gonna go to our derivative and see, okay, which one will give us a slope of, it looks like it should be 1 or something that's positive. So we have 2 times 2 over 2 times 2, which is 4, and then over 4. So it looks like this one will give us that value. This one, B, will also give us a slope of 1 because it's 2 times 2 over 4. And then over here, we have 2 times 2. This is 8 over 4. So this will be 2. So it looks like maybe C is not going to be the correct answer. And then D definitely continues to increase. So I feel like, unfortunately, again, we're just plugging in values. The only thing that we have to look at here is, I think it's going to be A or B. So now you have to look at other points. So again, the unfortunate part is you have to look at some points. Let's look at, for example, -2 and +2. It looks like you still have a +1 slope or positive slope. You can just say that. So if you were to plug in, which we said our options were A or B, if you were to plug it into A, you will get a negative value because the x will make it -2. So the only option that we have now is B. This is one of those unfortunate situations where you're just going to have to plug and chuck. Plug and chuck, plug and chug. I read that every time and I think it's plug and chuck. Chuck, but I think it's chug. Yeah, so x, and someone said x does not affect the derivative, so you're right, it has to be B. Dang. Plugging and chugging. Chugging and plugging. Yeah. Okay, let's go to, damn, should I be concerned about this? I mean, we're just going to assume, guys, it's free. It's good. All right, let's go to number 14. The weight of a population of yeast is given by the differentiable function in grams, and T is measured in days. The weight of the yeast population increases according to the function dy over dt is equal to ky. Right away, when I see this, you should think like, oh, this is going to be a C times e to the ky. I'll explain this in a second. Where k is a constant where k is a constant. At time t is equal to 0, the weight is 120 and is increasing at a rate of 20 grams per day. Okay, so I think what we got to do is we just got to go back. Yeah, I'm just going to write this down. Whoops, I realize that I'm not over here. Perfect. Okay, so I'm going to number 14. Over here. So we have dy over dt is equal to ky. By the way, when you get something like this, automatically this is y times is equal to c e to the kt. You can actually work this out by using separation of variables to get that answer. Okay. One of the things that I will mention is that when t is equal to 0, they tell us y is equal to 120. And if you were to work this out, 120 is equal to c e to the k times 0. Well, then you will get that 120 is equal to c. I just wanted to work that one out. Y is equal to 120 e to the kt. And then they tell you that the rate, the height is, the grams is increasing at a rate of 20 grams per day. Well, that will tell me right away when they have the problem and they're mentioning, well, t is equal to 0, it is increasing at a rate of 20 grams per day. Well, this 24 represents quite literally the value of k. Now, why is that the case? Well, if we have dy over dt is equal to k times y. Now remember, y is already grams. So the k value is just going to be 24 grams, like 24y. So our solution should be y is equal to 120 e to the 24t. And our solution should be A, or A. I'm hoping that's A. Yeah, so basically if we derive and plug in 0, it should be 24. The value of C should be 120. That's what it's saying. So one of the biggest things here is just that when you have dy over dt is equal to ky, well, that automatically just states that that's it. That's going to be an exponential. One of the answers should be this one, A or B. Okay. Now, 120 is already the initial value. Again, when you have these problems, this quite literally means the exponential. So, I think I got something wrong there, and we'll talk about it in a second. Wait, because someone said no, sub y is equal to 20 into it, and to find k is equal to 150. And increases at a yeah. So let me show you guys. I might have to do some push-ups. So, okay, our problem was this. The initial condition, again, if I were to plug in 0, I should get 120 is equal to c e to the k times 0. 120 is equal to c e to the 0. E to the 0 is 1, so 120 is equal to c. So our solution is already 120 e to the kt. Now, going back to your problem, the weight of the yeast is 120. Okay, and it is increasing at a rate of 24 grams per day. That means that after 1 day, the value is 24. So that means that when t is equal to 1, y is 24. So 24 is equal to 120 e to the k times 1. And then if you divide the 120 to the other side, you get 1/5 is equal to e to the k t. See, no, that wouldn't. No, k is not 1/5 because then we still have to take the natural log of that. So natural log is 1/5. See, the 120 is what throws me off. I don't know why. Maybe it's the fact that I've been doing this for 2 hours, but I don't know why I'm getting confused with this. Because again, we have this equation and the weight, okay, going back to this slide over here, the weight of the yeast is 120 grams and is increasing at a rate of 20 grams per day. So that means that 24 is equal to ky. 24 is equal to ky. So then that must mean, see, this is what it doesn't make sense, because then what, 24? We don't know what k is. I will assume that 24, no. I feel like 24 is the correct value. I don't know why it's 1/5. It's B. Why is it 1/5? Sub 120. Oh, sub 120 into dy over dt. So like I do one, that doesn't make sense because 120 is the number of grams per day. The only thing I would do is like if I took the derivative of this function, oh, there it is. I will have 120 times k e to the kt. See, and this is what's, and if it is changing, 24 is equal to 120 k e to the kt. This is 1/5. If I divide the 120 to the other side, k is equal to e to the kt. The issue here is that when I take the derivative of that, 24 is equal to 120k, but that's assuming that I know what is happening. I'm genuinely like, maybe I'm just not processing what's going on because wow, I cannot believe this is so embarrassing, guys. But what is going on? We know the initial value is 120. It is increasing at a rate of 120 per day. So that means after 1 day, so I guess we should just, well, this is the only thing. We know that dy over dt is equal to ky. So after 1 day, we know that the rate is changing at 24 is equal to 24. And we know that the initial value is 120. So when we divide this, we get 1/5 is equal to k. This is quite literally the only way you can find k. And so y is equal to 120 e to the 1/5 t, which will make your solution equal to b. That will be my only logic. What I'm just confused about, I guess I'm just thinking of like a pre-calculus course where they kind of tell you like, oh, after one day, then this is the value. But this is how I will leave it. So that will be the logic as to why it's B. The whole point is you got to find the value of K. Wow. All right. Forget about it. It was shit. We move on. But damn, guys, if this happens, you got to tell yourself, all right, this is what it is. It's not worth, trying to get like missing that, and we just move on. So now we have to kind of do a problem here that involves, yeah, hopefully I agree. Hopefully we won't get a problem like that. It's pretty wild. But if you do, again, it's a multiple choice. Just move on, man. It's one of those things that like if you get stuck on something, kind of like I did, no push-ups, no push-ups. Then we'll move on to number 15. So we have the graph of f and g. Which of the following statements is false? These are confusing because you're trying to find what is false. So a lot of the times I'm like, yeah, that's true. That's my answer. So let's look at the first option. The limit as x approaches 1 of f of x is equal to 0. Well, we have the graph of f. Well, the limit as x approaches 1 is 0 because if you notice from the right and from the left, it's equal to 0. F of 1 is equal to 2. So we know that's true, so we cut it off. The limit of g of x does not exist at x as x approaches 2. And that's true because if you notice from the right, that's going to be -1. From the left, the answer is going to be 1. So the limit does not exist. It is a jump discontinuity. So we know that this is true, so we cut it off. Now we go to the next one. The limit as x approaches 1. Oh, these are interesting. So the limit as x approaches 1 of f of x times g of x plus 1. Well, if you plug in 1 into the first one, or if you take the limit, because remember, you can take the limit of them separately, we know that the limit is 1, but then the limit of the other one does not exist because this will be 1 plus 1, which is going to be 2. So we know this is true. And then we get to the last one. the limit as x approaches 1 of the first function, so f of x plus 1. So we're really looking at 1 plus 1, which is going to be f of 2, and that does exist on the graph. And then g of x, wait, we're looking at which is false. Oh my gosh. What am I doing? I feel like I need a break. 24, yeah, 1/5 push-ups. That's exactly what it would do. Not 120. Hell no. Guys, what's the answer to this one? Because you're saying which one is false. I am so confused right now. 2.5 hours of doing this, and somehow my brain is just not processing, or I'm like getting in my head. Wow. So let's see which one is false. My goodness. The first one, we know the limit as x approaches 1. We know that's true. So we cut it off. Which one? The limit does not exist. The first one, that's true. After this one, I'll do 1/5 push-up. And then this one, the limit does not exist. So let's see. The limit of f of x is the limit of the first one as x approaches 1. We know that exists. That's 1. And then the limit as g of x plus 1, which is the limit of g of 2. Because it's like this function that's translated does not exist. But how does C exist? We're looking at limit as x approaches 1 is 0. And then g of x plus 1. Someone's saying it's C. It says C because f of x approaching 1 is 0. Then g of x plus 1 approaches 1 is 1 plus 1 is 2. See, I was thinking of plugging the value in and multiply as well. So the first one, okay, we know the first one is true. So that's we cut it off because again, it's what's false. So the limit of this is equal to the first one does not exist, or the second one does not exist because the limit as x approaches 1. Then we go to the next one. The limit of f of x, so we can plug it in separately. Again, that's kind of like the whole point. Okay? The limit of the first one exists. We know that's going to be 0. And then the limit of the next one does not exist. Well, the limit of the next one, which is g of x plus 1, that does not exist. So this product, you have something that exists times something that doesn't exist. This does not exist. I feel like that's true. And then this next one, you plug in 1, f of 1 plus 1, which is f of 2, that exists, times g of 1, which is 1, because if you look at the function, that exists. So this exists. So this is true. We're looking at something that's false. See, that's so what I would do in this problem, we know that A and B are true, so we're just gonna go with that. What I would probably do is I would plug in something I would do left-handed integrals, to be honest. Like for example, something that approaches 1 from the right-hand side. So something that approaches 1 from the right-hand side for f of x is gonna be like, let's just say it's like something, it's like close to 0. And then something that approaches like this will be like 2.1. See, it approaches -1. So this function is almost like 0. And then you do it from the right-hand side, that's also 0. And then you do it from the left-hand side, that's also 0. And then you do it from the left-hand side of the other, that's also 0. Or that's going to be 1. So you have 0 times 1, that's 0. So this exists. No, yeah, actually, that's what it is. So if you do left-handed integrals, this exists. So this is false because they're saying that this does not exist. C does exist. Because if you do it from the left-hand side, they both equal 0 because of the f of x. That's the value. The f of x makes it equal to 0. Because again, I'll do it again. I'm just going to draw this out. This will be important for us. Actually, I'm just going to show you here on the graph. As we approach 1 from the right-hand side, it's 0. And then as we approach 1 from the right-hand side, so think of it like 1.1 plus 1, that's 2.1. We're going to get like -1. But regardless, you're multiplying it by 0. This f of x will always be 0. Therefore, this will exist. So it's going to be C. Wow. Wow. Okay. Let me do my push-up. Let's start with 1/5 push-ups. We'll start with that, and then we'll do some other ones, and then we'll go to the next problem, okay? 1/5 push-ups. And then start looking at problem number 16. I'm done, chat. I'm done. Okay. Clear mind. Let's go. Okay. Let f be a function. F of x is equal to this. What is the largest open interval on which the graph is concave up and increasing? Oh, this one's interesting because you're looking for something that's concave up and increasing. So we're looking for something that's increasing and something that will be concave up. So first thing I'm going to find is when it's increasing. So what I would do is take the derivative. We got to find our critical points. That's going to be 12x minus 6x squared. Is that equal to 0? Let's factor out a 6x, and we get 2x minus x. I'm sorry, we get 2 minus x. And so x is equal to 0 and 2. So we have two intervals. We have 0 and 2. And we can sort of just like, again, plug in values like -1. I want you to kind of like work this out on your own. Maybe, again, write it out. But we will get like -6 times a +3. So this will be negative, and then you plug in 1, then you're going to get something that's positive, and then you plug in x is equal to 3, and you will see that this will be negative. Okay, so when is it increasing? Well, it's definitely increasing from 0 to 2. We're looking for when it's also concave up. So let's take the second derivative. Okay, so this will be 12 minus 12x. Is that equal to 0? You can just factor out a 12 if you want to, or move the 12 to the other side, however you want. So this will be 12, 1 minus x. So we have x is equal to 1. Okay, so I'm just going to put the interval kind of a little over here on top. We have 1 here. When you plug in, let's see, when you plug in 2, you would get something that's negative. And when you plug in, let's just say 0, you would get something that's positive. So remember, they were asking, where is it concave up and increasing? And that will be this interval right here from 0 to 1. Because if you notice, that's where it's concave up, and that's where it's increasing. So we write interval from 0 to 1. Let's go back to our slideshow over here, and we will get A. That's it. Okay, 17. A particle moves along the x-axis and it has this position. What is the first time at which the particle the velocity of the particle is 0? Interesting. So this is just like a trig function. Let me write it out real quick, and then we can kind of see what you can do. So remember, what is the first time the velocity of the particle is equal to 0? So it's just asking you, find when the derivative is equal to 0. Well, this is really just testing like some trig functions. Because when you take the derivative, you're going to apply product rule. I'm going to take this as my first derivative, or my first function, and the next one's the next function. So when you have -12 e to the negative t, sine of t, so the derivative of the first, plus 12 e to the negative t, cosine of t. So now from here, I can factor out let's factor out a -12 e to the negative t, just because I want to move my functions around. You're going to see in a second. Now I'll have sine of t minus cosine of t. So this function never equals to 0. It just never does. It's always just going to be, in this case, it's just decreasing and it's negative. So it's never equal to 0. So what we're really trying to find is when the sine of t, cosine of t equal to 0. In other words, sine of t is equal to cosine of t. And guys, this happens if you remember your your unit circle, pi over 4, and it's going to also equal at 5 pi over 4. That's where we'll have the same values. But then they're asking for the first time it happens. Well, that's going to be pi over 4. So it will be solution A. Okay, let's go to B. Let capital F be a function, or 18, there you go. Let capital F be a function by capital F of x is equal to this. Which of the following is an expression for f prime? Guys, come on, second FTC. Your immediate answer should be C. And a lot of people will probably choose, or I'm sorry, it's going to be D. Right? Yes, it's going to be D. I don't know why I was going to choose C because I was taking the derivative of 1 here, but it's the original function. But in this case, you just plug in x. You're using second FTC. If we go to 19, let f of x be a function. What is the approximation of 1.5 using the line of the tangent to the graph of f at x is equal to pi over 4? I say pi over 4, pi over 2. I'm just saying things. What is going on? Let me write this problem down. Let me go back over here. And then I'll bring you guys back to the iPad. F of x is equal to 2 cosine x plus 1. By the way, this is why I mean that tomorrow should just be like a very, very mellow, chill day. You guys should not be stressing out and like kind of crunching, kind of like I'm doing here. This is why I'm not going to do a live tomorrow. Because you guys should really just take it easy tomorrow. And just make sure you can rest your brains because, again, I'm already kind of just rambling on. I've been going on for 2.5 hours. And as you can see, mistakes can be made. So keep that in mind. Tomorrow, be very kind to yourself. One push-up. One push-up today? Okay. So we got to find the approximation. So we got to find y minus y sub 1 is equal to m times x minus x sub 1 at x equals pi over 2. So let's take our derivative. So this will be negative 2 sine of x plus 0. And then when you find the derivative at pi over 2, you get negative 2 sine of pi over 2. Guys, that's just a big fat negative 2. Okay, but when you plug this to the original function, because we also got to find the y value, so this will be f of pi over 2, which is 2 cosine of pi over 2 plus 1. Cosine of pi over 2 is equal to 0, so plus 1, so we just have 1. So we have y minus 1 is equal to negative 2 times x minus pi over 2. So what we got to do is plug in or approximate 1.5. So we got to plug in, we got to plug in 1.5 into here. No way. I'm going to change it to 3 over 2 minus pi over 2 just because I feel like I'm going to have to change it. Because if you look at your answers, I'll bring it back. The problem we have like negative 2, 1, pi of minus 2, and 4 minus pi. So especially for a non-calculated portion, maybe change it back to your fractions. Okay. So let's go ahead and how about we just I guess. Oh, well, what am I doing? When I distribute the negative 2 into here, you will get negative 3 plus pi. Oh, thank you. Thank you. My goodness. So you have y minus 1 is equal to negative 3 plus pi. Let's add the 1 to the other side. It will be pi minus 2. Now, why did I get that? So y is equal to negative 2 plus pi, and I just switched it around. Pi minus 2. And that's your y value. So there you go. Pi over 2. Or pi minus 2. All right. Let's go to number 20. Okay. One pusher for forgetting the 1. Ugh. If someone says to do, if you guys all agree, I'll do a 1 pusher for forgetting the 1. I'll do that. Ooh, this sounds interesting. Okay. So let f be a function. I feel like I'm going to miss this one. I don't know why I feel this way. Let f be a function given by f of x is equal to x minus 2 over 2 and an absolute value of x minus 2. There's a reason why these problems are given. Which of the following is true? Okay, so they're saying that the limit as x approaches 2 of f of x is 1/2. Well, let's see if that's the case. Now, okay, I'm going to show you guys, especially for absolute values, it's very important that you really look at the one-sided limits, okay? Because if I go back to the blackboard, I want to find the limit as x approaches 2 of f of x. In other words, I need to find the limit. I guess I should split this up. I should find the limit as x approaches 2 from the right and the limit as x approaches 2 from the left. Because you're going to, the absolute value, especially with these, you have to really look at that carefully. Something close or something that's to the right of 2, let's just say it's like 2.01. You have 2.01 minus 2 over 2 times 2.01 minus 2. Well, in this case, this is harmless. This just cancels out, like the top and bottom just cancel out, so it's 1/2. But look at the other side. As we approach 2 from the left, what do you say, 1.99? We have 1.99 minus 2 over 2 times 1.99 minus 2. Now, this is the important part. On the absolute value part, it's just 1.99 minus 2 is like negative 0.001. But then, because it's an absolute value, it turns into a positive. But the top does not. That one still becomes a negative. So this technically becomes -1. So what you have is -1/2. So the limit does not exist. The limit is 2 different values from the left and right. So you can technically say from the right, it's 1/2. From the left, it's -1/2. So by the way, you're going to have a removable jump discontinuity because the limit does not exist. We know that's not true. F has a removable discontinuity. That's not the case. Typically, that's when the limit exists. You have a hole, and then you just the function is defined at a different point. F has a jump discontinuity because we just show that the limit is 2 different values, one from the left and one from the right. And then F has a discontinuity due to a vertical asymptote. I don't think we can say that, or I don't think we should say that, because it technically has a hole because the top and bottom are the same values. So the only time this will be a vertical asymptote is if the top wasn't an x minus 2. Now, can you use L'Hopital's rule? I will be very cautious just because you have the absolute value. Be very cautious with that. With the absolute values, you have to essentially just say, you know what? Plug and chug, whatever it is. Yeah, you have to just be very, very mindful of that. Okay? Guys, there's a few new faces on here. Do not forget that what you can do with these problems, or what you can do after this, is go to the Discord. Okay? I posted the link, and if someone is on here, please post the link as well, because I know people are wondering about that. Let's go to 21. F of x is equal to the natural log of x. Then this limit, guys, this limit is the definition of the derivative. This is the function, or the derivative of the function at 3. So you should ask yourself, what's the derivative of the natural log of x? 1 over x. At 3, 1 over 3. A. Okay? You can use, by the way, if you can plug it in, you can do like one. You can plug in the natural log of x. You can do ln of x minus ln of 3 over x minus 3. You plug in 3, you get 0 over 0. L'Hopital's rule, you're going to get 1/3. That's totally fine. So L'Hopital's rule, you can. But you shouldn't use L'Hopital's rule on the absolute value. Which of the following is a solution to the differential equation dy over dx with the initial condition y is equal to 0? Wow. This is a pretty good one. And I don't know how you want to solve this. Wow, this is good. What I will probably do, in my opinion, I think the answer is going to be D. That's my guess. If not, I'll do some push-ups. But I'll tell you why. Just because I already know that when we take the integral of 1 over 2x plus 1, we're going to have that natural log. But let's just kind of write it out, because this will give us a practice problem with differential equations. So we have dy over dx, 2y over 2x plus 1. And then we have the initial condition that e, or y is equal to e when x is equal to 0. So let's check this out. We're going to take separation of variables. So what we're doing is, I think I'm going to be incorrect in my guess, but we'll see how that works. So we're going to have 1 over 2y dy is equal to 1 over 2x plus 1 dx. So basically what I did is I divided the 2y to the other side to make it 1 over 2y on this side, and then I multiplied the dx to both sides. Okay? Because now what we can do is we can integrate 1 over 2y dy is equal to 1 over 2x plus 1. By doing use substitution, you get 1 over 2 natural log absolute value of y is 1 over 2 and natural log 2x plus 1. And then I'm going to add my plus cheese here at the end. Okay, so let's plug in our initial condition that they tell us that when x is equal to 0, the y value is equal to e. We have 1/2 natural log of e is equal to 1/2 natural log of 0 plus 1, because 2 times 0. Natural log of 1, this entire thing is 0, so we get that on the left-hand side, we just get 1/2, because natural log of e is just 1. We get that 1/2 is equal to c. So now what we have is 1/2 natural log of y is equal to 1/2 natural log of 2x plus 1 plus your 1/2. Let's divide everything by 1/2. You'll notice that everything here just cancels out. And then we can go ahead and take the e of both sides. So y is equal to e to the natural log of 2x plus 1 and then plus 1. So then the answer is just e times 2x plus 1. Oh my goodness. So if I simplify this is e2, I guess I'm just going to write this a little better. What, like 2ex plus e? This will be our solution. And if you look at this, guys, I was incorrect. I said that the solution was D just because I was thinking of the integrals. But dang, this is what happens when you try to do stuff in your head. The answer was this, B. Yeah, hopefully you guys don't remember what I said about that. Okay, the region enclosed by the graph, y is equal to x squared, and 2x is the base of a solid. For the solid, each cross-section is perpendicular to the y-axis. It is a rectangle whose height is 3 times its base in the xy plane. Which of the following expressions gives the volume of the solid? This is good. Okay, so let me just put this on my iPad. Let me write it out, draw it out, and then I'll bring you guys over in a second. So we have this function, and then we have this function. So y is equal to 2x, and then we have x squared. And I'm assuming this is going to be on the bottom. I think it's going to be on the bottom because 1/2. Where do they intersect? Just give me x times x minus 2. So x is equal to 0 and 2. Okay. 2 and 2. Okay. I think this is going to be fine because at 1 it's 2. Yes. Okay. So it's going to look like this. All right. So let me now go back to my blackboard. All right. So this is what we have. But they tell you the cross-section is perpendicular to the y-axis. So the cross-section looks like this. It is in this direction. So we should already change this function, which was the x squared, in terms of y. So this will be root y is equal to x. And then this function would be y over 2 is equal to x. Now, they're talking about the cross-section is a rectangle. Now remember, they tell you the rectangle, this will be our base, and they're telling you that the height is 3 times the base. So this is how we will draw it out. So then the area of this is 3b squared. Well, what we got to do, what's going on here, there we go, is our volume will be the integral from some bounds. We need to figure out where that happens. We know that they intersect at 0 and at 2, but we need to find the y value that they intersect at. And in this case, you'll see that it's equal to 4. You just plug it into one of the functions. So we have the integral from 0 to 4 of 3b squared dy. But remember, since this is in terms of y, or we need to find the b term, which is this value right here. This is our b. We need to find the difference between the right function, which is root x, minus the left function, which is y over 2. Or I said root x is root y. So the volume is equal to the integral from 0 to 4 of 3 root y minus y over 2 squared dy. And then, luckily for us, we don't have to solve this. We go back to our problem, and then we go to A. So Google link. All right, let me go ahead and send the Google link drive. Guys, and I'm just going to say this right now. I know that a lot of you guys are in here and you're like, oh, I'm doubting myself. Please, I want you to remember that though these might be hard right now, especially when you're studying, you're like, I have no clue what's going on. During the test, it's going to click. It always does, especially when you've been working hard and you've been studying. This will always happen. I'm going to go ahead and post the Google Drive here. Okay. This has a Google Drive of a bunch of different questions, whether it's going to be FRQs or MCQs, just things that I found in the past. I would highly recommend that you just kind of look over that. Okay. Also, you can go to the Discord, and there's a lot of people studying right now. And you guys can go on there and you guys could ask questions to a lot of different people. But just know tomorrow I'll be on the Discord and I'll be yelling at all of you guys to go to bed because this is it. Okay. Let's go to number 24. I want to do a couple more problems and then this is it. We're going to call it. We did a lot of FRQs in the previous live that was yesterday, so you guys are more than welcome to go to the lives that were in my previous playlist, and you guys can watch that as well. And then you guys can replay this if you want to. But again, at this point, practice as much as you can. You know, for the most part, I would do it MCQs or at a minimal, and I would definitely focus on the FRQs. So let's go to 24. If the average value of a function from the interval -2 to 4 is 12, what is that value? Well, average value, I'm already thinking that I have to do 1 over 4 minus -2, integral from -2 to 4 of f of x. And that's going to equal to 12. I'm writing this on my iPad, and then I'll bring you guys on over so you guys can see what that is. And let's see, maybe the answer is already 12. I don't know. Okay. But if I go here, we have dx. Let's just simplify this because this is the average value. They're saying the average value is equal to 12. Well, let's just go ahead and simplify that. What I have is 1 over 4 minus -12, so, or -2, I'm sorry. 1 over 6, integral from -4 to -2 to 4 of f of x dx is equal to 12. So then we can just say that this integral is equal to 72. So what they're asking for is now we want this. Whoops. Shouldn't have erased that. They want this one over here. They want this one. Okay, well, let's do it. If we factor out the 1/8, integral from -4 to 2 of f of x dx, hey, guess what? We know this integral alone is 72. So this is just 1/8 times 72. And that's just equal to 9. That's it. 1/8 before 1/8 before f of x. Did I not write that? I'm trying to see. 1/8 before f of x. I feel like I wrote that correctly, but let me know if I wrote that incorrectly. I hope that's not the case. Okay. 1/8 before f of x. I feel like that I did that. I hope I got this right. Maybe I hope I did my math wrong. Yeah. Let's do 25. Oh, this is interesting. So they gave us g of x and they gave us f of x. And then they tell us, okay, if h of x is equal to the product of f of x times g of x. Okay. I'll do one more problem and then we'll kind of do like a last minute just pulse check just to see how everyone's doing, and then we'll do a some push-ups, and then we'll end the stream. This will be our last problem, guys. But again, we'll talk about it in a second. We have h of x is equal to the product f of x times g of x. Well, don't forget, we have to find the derivative at 2. Well, let's just kind of talk about the derivative real quick. It's product rule. H prime of x is equal to f prime of x g of x plus f of x, g prime of x. So then h prime of 2 is equal to f prime of 2, g of 2, plus f of 2, g prime of 2. Now, we know nothing about the functions except we know their graphs. If we look at this, f of x, first of all, at 2, we know that g of 1 or g of 2 will equal to 1, and f of 2 will equal to 3. And then f of 2 will equal to 3. And the slopes, remember, these are linear functions. So the slope or the derivative is 1 over 2, so 1/2. So I can say f prime of 2 is 1/2 regardless. And g, you can just take any 2 points. I'm going to look at at 2. It looks like you go down 2 over 1. So -2. G prime of 2 is -2. So let's go ahead and go back to the iPad. I wrote those problems down. So h prime of 2 is equal to f prime of 2, which we said 1/2, times g prime or g of 2, which we said was 1, plus f of 2, which was 3, g prime of 2, which was -2. So 1/2 minus 6. 1/2 minus 12 over 2 is equal to -11 over 2. Huh. Okay, hope I got that right. There it is. All right. Now, just in case people can't find this, I am going to go to chat real quick, and I'm going to drop this in the chat. Okay? Oh, you guys, this has been so fun. So fun. Let me go back to here. Don't forget, let me just post this in the chat. Give me 1 second. There it is. Yeah. One thing that I would say, okay, is that there's a lot of different there's a like a playlist that you guys can look at. I'm actually gonna go and I'll show let's go here. Okay, here's the AP calculus speed run that we just did. We have this one, the AP calculus AB review. You guys can look at, I mean, there's some predictions there. I have a playlist that is where is the AP calculus? Where's my AP cal? Oh, here it is. Okay, 32 videos. You don't have necessarily need to do those, but there's a couple FRQs, especially at the very end. There's like a free response question that I did a couple years ago, so you guys can definitely look at that. And yeah, you guys can look at my shorts. You guys can look at my TikToks, my Instagram reels. But for the most part, I want you guys to remember that you guys can go on the Discord that I think I've linked below. And guys, oh my god. By the way, I'm not bald. I just like to. But anyway, this has been fun. I mean, what can I say? You guys are the greatest. The fact that there's 48 people in here. Let's send the Discord invite. I'm going to send it again. I'm going to send the Discord invite here. Okay. You guys can always go on the Discord and just chat with a bunch of people. Tomorrow, I'm still going to be on there. Tonight, I'll still be on there. And just to answer any questions. On Sunday, I'm just going to go in there and just be yelling at all of you guys to go to bed. This is it. Tomorrow, you guys should obviously, be reviewing more stuff, but just I want you guys to be chilling. Sorry, I got hiccups from the Coke there. But I'm just so grateful. Last year and the past few years, I've been making videos like this, and people are always saying that I should do, live streams and I should do review. And now I have the opportunity to do that because of, people like you. So you guys are paving the way for the next future students. Someone's going to be taking the AP exam. Maybe they're going to be watching this a year from now. And you guys are the big reason why we have these things. Maybe next year I can do like a whole 24-hour stream. You might not benefit from it now, but you will be the reason why this exists. And I just want to say thank you for that. But when it comes to the test, get some rest. At this point, you guys have done plenty of material. You guys have done just so much already. You've done the work. You're ready for this exam no matter what you think. and you're taking the exam. There's a lot of people that have never done this in their lives, and this is a rite of passage. And I will say a big congrats to you guys. It does not matter what the score is. It really doesn't. And I know a lot of people are always hung up on, I need to get a 5 because I need it for college credit. No one gives a fuck after that. Okay? It's not going to matter whether you fail or you do really well. Everyone's going to be in the same level once you guys continue forward with your careers. That's all I will say. And I believe in you guys. I'm just so grateful that you guys are here. You guys are just amazing. I don't know any of you guys, but from one stranger to another, let's fucking go. Seriously. I'm gonna be again on Discord on Sunday. Tonight maybe. By Sunday night, that Discord should be radio silent. I don't want to see any of you guys on there. Get some rest. And yeah, be kind to yourself, study as much as you can. But if you feel stressed, I would suggest just drop it. That's it. Okay. Don't overwhelm yourself. It doesn't matter. I want you guys to try your best, but I also don't want you guys to kill yourselves figuratively over it. So definitely be easy on yourself, be kind to yourself. I want to hear how it went. Go on Discord. I want to hear the chatter. Go on my TikTok, comment on Instagram. And yeah, I can't wait. I just want to say from the bottom of my heart, thank you. I took this exam back in 2007, and I wish something like this existed when I was a student. And now, I'm paying it forward. So just thank you. Yeah, thank you guys. And good luck. Okay? This is fun. I'm so happy we did this, and I'm so happy we continue to do this. So be good to yourselves. Be good in general. I'll see you guys in the Discord. See you on Instagram. See you on TikTok, wherever. And yeah, let's kick some ass on Monday, okay? I want to hear how it went. Oh, and on Wednesday, when the tests get released, be on the lookout. I think I'm going to post on TikTok and on Instagram on the problems. And maybe I'll just do a live stream reviewing those things and then just kind of go from there. Oh, okay. Push-ups. 10 push-ups, maybe? 10? That's it? 10? What do you think? 10 is fine? That's it. That's it. That's it. All right, you guys. This was fun. Love you guys. Truly, love you guys so much. This has been the best, and I wish you the best. Kick some ass. Let's do it. See ya.